Good morning, everyone. So please let me know whether audio video is clear or not. Please tell me. Is audio video clear? Tell me, guys. Is audio video clear? So good morning everyone. Good morning. Okay, so in today's class we'll start with the marathon session of signal and system. Signal and system is again a very simple subject and it's a mathematical subject. So I'm going to revise the basic part first, and then Ankit Joshi sir will join at 12, and then up to 2 p.m. this class will be live. Okay, so this is a marathon session for 4 hours. The first part, which is which part is, I mean, it's taken by me. That part is the basic part of the signal and system and the LTI system. Okay, so I'll teach you about the basics and LTI. Okay, so let's start the session, guys. I think many students have joined, so let's not waste the time and let's start the session. So this is my introduction. Those who don't know me, my name is Asu Jangda, and I'll teach you almost every subject. So right now I'm teaching signal and system. This series is Maha Marathon series, and in this series now the core part is also going to start. Core means electrical core and electronics core, like machine power system, power electronics and communication and EDC. You must have seen that. Okay, so the core part is also going to be start. Okay, there is one mega workshop which will be there on 15th of January, and it is taken by Abhinav Negi sir, but it is mainly for GATE 2024 students. So you can refer to your juniors, or you can also tell the students who want to prepare for GATE 2024, so they will get some success mantra or tips how to start with the preparation and how to get the ideas. So Abhinav Negi sir will take this class on 15th of Jan. So don't forget. And there is one more thing. If you want to get some scholarship on the courses, so you can register on the link which is given below in the below the video. So you go the link, and then you can register there. Okay. Aptitude Express is also going to start, general aptitude, so it is coming soon, and it will be taken by Rakesh Talreja sir. So, and there is one more marathon session for signal and system which will be again coming soon for mathematics. Okay, so let me tell you guys, right now it's time for the test series, so better you join the test series, because test series will let you know what type of mistakes you are doing. Okay, so in enhancing your preparation, test series is very important, so better you join the test series. And BYJU'S exam prep is also providing you the test series. Okay, so you can join the test series. There are 60+ tests, and including the mock test, and the interface is again same like the IITs provide you in the GATE exam. Okay, so you can join it. And before starting the session, subscribe the channel if you have not subscribed us, and like the session and press the bell icon, so that whenever the session is live you can get the notification. Okay, so let's start the session, guys. Let's start it. So let me tell you the starting part of the signal, because I'm starting with the signal and I have taken some questions on signal. So what I'm going to do is I'm going to start with the signal part, and then I'll switch to system, and then I'll tell you about LTI system. Okay, so let me tell you, in signals, the first thing is operations. In signal, the first thing is operations. Operations means shifting, scaling, shifting plus scaling, inverting, differentiation, integration. Okay, so these are the operations that we need to understand first. Now, in those operations, the most important operations are shifting, scaling, inverting. Okay, so these are the most important operations. So based on these operations, I have selected one question. Okay, because based on this question, I'll teach you something. Now the question says, let's look at the question. So this is time axis, and this is my ft. So some signal is provided to you. Okay, some signal is provided to you. You can see that it starts from -1 and it goes to 1, and the slope is you can say the slope is half. Okay, and then it remains constant up to 2 seconds, and then 2 to 4 it goes down, and the height here is 2, and here the height is 3. Now what we want to do is The signal ft is shown below. It means in the graph ft is given. The value of f k1t plus 2 is 1.5. The value of this function, now this function is a scale, it is also shifted and it is also scaled. So both operations are applied, shifting and scaling. Now it is given that ft equal to k1t plus 2 is equal to 1.5 at t equal to 4 seconds. At t equal to 4 seconds, the value of this function is provided to you. Find the value of k1. We need to calculate the value of k1, and this is m. Okay, can you hear me? I think there was buffering. Okay. So there was some internet glitch. So there was some internet issue. Tell me now, is it clear? Okay, that's fine. Now try to solve this question, guys. What can be the possible answer? Tell me, everyone. Please do it fast. Okay, let me try. Let me teach you about shifting and scaling, and let's try this question. Okay, let's try this and try to understand the meaning of shifting and scaling. Now you can see that this is the shifted and scaled version. We have shifted the function. Now first of all, please tell me, let's say some ft is provided to you. Some ft is provided to you. How you plot some f of k1t plus k2? Let's say you need to plot this. How you are going to do this? Tell me, guys, what should be the process? There can be multiple processes. There can be multiple ways to plot this function if ft is provided to you. What are those multiples? What are those multiple methods? So out of those multiple methods, I'll tell you the basic part. The simplest method, which I think it's the simplest for me. I hope it will also help you. So whenever some function is provided to you, like ft is provided, and you need to plot k1t plus k2. So what you do is, first you plot f of, you remove this k1, f of t plus k2. First you shift this function, okay? First you shift this function, and then after shifting, you scale this function by k1. Once you get this, then you scale it. Then you scale it by k1, okay? So it is the simple part by which you can plot the function. Okay, these are the steps you need to follow. First, you have to remove this scaling factor. Don't take it common. You have to remove this scaling factor. So first you plot this t plus k2, and then scale the function. You know how to scale the signal, and you know how to shift the function. So it's easy peasy. Now let's look at this question. Let's look at this particular question. In this particular question, it is given that value of f of k1t plus 2 is equal to 3 by 2. Okay, it is equal to 3 by 2 at t equal to 4. So what you can do is, you can put the value of t here. So if you put the value of t, it will become f of 4k1 plus 2 is equal to 3 by 2. Is it fine? And in this graph, you can see that 3 by 2 value comes at 0, t equal to 0, and the same value comes at t equal to 3. At t equal to 3, you are getting the same value, 3 by 2. It means 3 by 2 is equal to f of 0 also equal to f of 3. You can do like this. We know that in the original function, the 3 by 2 value came at t equal to 0 and t equal to 3. So what we can do is, this 3 by 2 equal to f of 0 and f of 3. So on this side you have 4k1 plus 2, on this side you have 0, and you have one more term, you have 3. So what you can do is, from this relation I can say that 4k1 plus 2 must be equal to 0, or 4k1 plus 2 must be equal to 3. Is it fine, guys? So from here you can say that k1 is equal to minus half, and from here you can say k2 is equal to, tell me, guys, it will be 1 by 4. Okay, so there will be not k2, it is k1 again. So there will be two answers. Okay, there will be two answers. One is minus half and one is 1 by 4. So you can easily solve this question. So answer is minus half and 1 by 4. Answer is Agra and Calcutta. Tell me, guys. So there are two answers, Agra and Calcutta. Okay, that's great. So I told you how to solve these type of questions. Remember, even if you scale or shift, it doesn't matter. Let's say you put the value of t. If you put the value of t, then this will become constant. The internal term will become constant. Okay, this term will become constant. If this term become constant, then it doesn't matter whether you have a shifted function or without shifted function. Now it's a constant number, you can see that, and its value is 3 by 2. So from the original function, you can say that value 3 by 2 came at t equal to 0 and t equal to 3. So what you can do is, you can also say that this must be equal to f of 0 and f of 3. Okay, like this. Now you can see that this is constant, this is also constant, and this is also constant, the internal term. Okay, so what you can do is, you can equate this internal term and calculate the value of k1. Okay, so it's again easy peasy. So I told you how to tackle these type of problem. Now, wherever this k1 is negative, then how to shift and scale? Let's say ft is provided to you, and I want to do one operation. I want to do some one operation. Let's say I want to plot f of minus 2t plus 4. How to plot this? Tell me guys, how to plot this? If ft is given, and then we need to plot this f of minus 2t plus 4, how you are going to plot it? The coefficient is negative. Whenever the coefficient comes out to be negative, what you can do is, first you take negative common. Remember my, try to understand my point. First you have to take minus common. You have to remove this minus. So if you take the minus common, it will become f of 2t minus 4. So better you plot f of 2t minus 4 first. Once you get this f of 2t minus 4, then we can flip it. We can invert it. Okay, we can flip it. But to plot this f of t minus 4, you have to plot f of t minus 4 first, because you have to remove this scaling factor. Okay, once you get this f of t minus 4, scale it by 2, you'll get f of 2t minus 4. Once you get this f of 2t minus 4, then you have to flip it. But the question is about which line you have to flip. You can make it equal to 0. The t came out to be 2. So at t equal to 2, you can flip the function. You'll get f of minus 2t plus 4. Now there might be some other way also, because some students know some student have some different kind of method. So you can apply your own method. I have no problem, but I follow this method. Those students who have studied from me, they can plot using this method. You can have your own methods also, because there can be multiple ways to plot this. Okay, so shifting and scaling I told you, and inverting I told you how to apply shifting, scaling and inverting, and what is the relation of this shifted function with the original function. Okay, once you put the value of t, then there is no meaning of shifting. Okay, once you put the value of t, then there is no meaning of shifting. Okay, this will become constant, so this will also be constant, this will also be, so you can equate directly with ft. Once you put the value of t, now it is not a function now, so you can say it is f of some value, so you can equate with the original function also. Okay, I hope you understood it. Let's move to the next question. Now in this question, what I have done is, I have taken some singularity functions. Now what are those singularity functions? What is the meaning of singularity functions? Let me tell you. Singularity functions. Okay, now the next thing is singularity functions. In singularity functions, we specially study about step function, especially unit step, step signals. Number 2, ramp signals. Number 3, impulse signals. Number 4, tell me guys, rectangular signals. Signum function, Signum t. Number 6, triangular function, triangular signal. Okay, these are the singularity functions, guys. I hope everyone know about step signal, ramp signal, impulse signal. This is these three are very important. Okay, these three are very important. Now let's try to take one question. Let's try to take one question and try to apply this, because I don't want to go into the basic level of step signal, what is the meaning of step signal, and because it's a pure time waste. If you have prepared, I mean, if you have studied signal and system at basic level, you must know how the step signal look like, okay? Similarly, the ramp signal and the impulse signal. So I'm not going to take the properties of these signal, but the important terms I want to tell you. But before that, I mean, before solving this question, I want to tell you some basic points, okay? First, step signal. You know that UT means unit step signal. UT means unit step signal. And the plot of UT will look like this. 0 and the height is 1, okay? The plot of UT will look like this. Is it fine? Now, since UT start from 0, if you multiply UT with some other function, let's say there is some function ft, and you multiply UT with it, what is the meaning of it? The meaning of it will be this product will become 0 for t less than 0. Why? Because for t less than 0, UT is 0. So if you make the product, it will become 0. So if there is some UT connected with some function, UT multiplied with some function, then you can say that this product will exist only after t equal to 0. Is it fine, guys? So remember this point. I hope you understood it. What is the meaning of ft into UT? Now, whenever you want to plot like this function, now minus f of minus 2t plus 4, like this. If you want to plot this function, how you are going to plot it? It's very simple. First of all, look at the coefficient of t. The coefficient of t came out to be negative. If the coefficient of t came out to be negative, it means you have to draw the signal in the left side, okay? Whenever the coefficient of t came out to be negative, you have to draw the signal in the left side. Whenever the coefficient of t came out to be positive, you have to draw the signal in right side. So remember, in singularity functions, you can apply this concept, okay? The coefficient of t will tell you in which direction the signal will be plotted. Now, we know that the negative coefficient is there. So you have to plot in the left side. From where it will start? The coefficient will tell you the height. Here the coefficient is 1. It means the height of the signal. The height of the signal is 1. And it will be on the left side. Now from where it will start, you can put the internal term equal to 0. So if you put this term equal to 0, minus 2t plus 4 equal to 0, you'll get the value of t. So the value of t came out to be 2. It means you can say that this function will start at t equal to 2. It will be on the left side and the height will be equal to 1. So what you can do is, if you want to plot this signal, you can plot it directly. It will start from 2, 1 and 2. It will start from 2 and the height will be 1. And it will be on the left side. You can see that. So this is the plot of this signal. I hope you understood it. Is it fine, guys? Tell me. Is it fine? I'll come to the periodic and aperiodic signal, Reshma. But first you have to understand this, how to plot this u of minus 2t plus 4. Is it fine? Now, let me tell you one more point. Let's say you want to plot u of 5t minus 10. Now tell me, guys, and let's say the coefficient is 2. Now tell me the height of this signal. Height is 2. Height is 2. The coefficient will tell you the height. Since the coefficient of t is positive, it means it will be on the right side. It will start from, you put it equal to 0 and calculate the value of t. So the value of t will be 2. So it will start from 2. So if you want to plot this signal will look like this. The height will be 2, okay? And it will start from 2 and it will be on the right side. It will be on the right side. Is it fine, guys? So this way you can plot it. This way you can plot it. It will start from 2 and the height is 2 and it will be on the right side. Okay, so I hope you understood how to plot the step signals. Now, there is a property of step signal. I can tell you on the basis of this rule, I can tell you the property. Let's say you want to plot u of k1 u of at plus b. k1 u of at plus b. Now, you can also say that it will be equal to k1 u of t plus b by a. Okay, like this function. You can also write this function as 2u of t minus 2. Okay, 2u of t minus 2. The graph of 2u of t minus 2 is again same. You can see that the coefficient of t is positive, so it will be on the right side. It will start from t equal to 2 and the height is 2. So you can apply this concept on this question also, and you will get the the simplified version of this this function. Okay, I hope you understood. So remember this property, but in this property, let me tell you guys, a must be positive. You have to take a as positive, you can't take a negative. In this question, if you want to apply the same property, let's say you want to simplify this function, you want to make the coefficient of t as 1 or minus 1. Now a must be 2, you can't take a equal to minus 2 here, you can't do a equal to minus 2 here. Okay, you have to take a equal to 2. So if you take a equal to 2, it will become u of minus t, because you have to remove this a here, plus 4 by 2. 4 by 2 is 2. Okay, so this function you can write like this. Now you can see that the plot of this function and the plot of this function will remain same. The coefficient of t is negative, it means it will be on the left side, and it will start from t equal to 2. I hope you understood it. Okay, I hope you understood it. So this is again very important case, so you have to remember about step signal. So these are the important points about step signal. Now if you look at this question carefully, I have taken the step signal and there is a summation of some step signals. Okay, there is a summation of some step signals. Now how to simplify it, how to calculate this question? Let's try this question now. Okay, so let me remove this because it's of no use now. So I can remove this part. Okay, I have told you what type of properties you have to apply. Okay, now whenever you have a signal in which there are some steps, in which the height is changing in steps, there is no slopey height, height is changing in steps. Okay, there you can apply this concept. Okay, whenever there is some signal in which height is changing in steps, okay, there you can apply this concept. Let me solve this question. Ft is given as 2u of 2t minus 6 plus 3u of k1t plus k2 plus k0 u of t minus 2 minus 10u of t minus 6. It is given that f of 7 equal to 0 and f of 5 equal to 7. It is provided to you. What can be the possible value of k0 and k2 if k1 is 2? So we need to calculate the possible value of k0 and k2 if k1 is 2. K1 is provided as 2. Remember, I think it is MSQ. I think it is MSQ because many students are giving only one answer. I mean, it can be possible that the answers are more than one. So please be careful. Let's try to check it. So what we can do is, first we will simplify it. The value of k1 is provided to you. The value of k1 is provided to you. So what we can do is, first let's simplify it. If you simplify it, it will become 2u of t minus 3, right? I have applied the AB rule. I have applied this rule. Okay, so A is 2. So I have applied this rule plus 3u of, tell me the value of k1. K1 is 2. So it will become t plus k2 by 2. Fine. It will be 3u of t plus k2 by 2 plus k0 into u of t minus 2 minus 10u of t minus 6. Is it fine, guys? I hope you understood it. Now I need to plot them. First of all, we can plot this and this and this. This is of no use. Why? Because you are looking the height at 5. If you are looking the height at 5, then this function is of no use. Why? Because this function starts at t equal to 6. It means it is starting after t equal to 5. It is starting at t equal to 6 now. So if you are looking at the height at t equal to 5, only these function will participate. Okay, there is no use of this function. Now what is the height of this function? If you are looking at height at t equal to 5, we know that this start at t equal to 6. So the height of this function is of no use. If you are looking for this function, let's say you are looking for f of 5. F of 5 means you are looking at the height of this function at t equal to 5. So at t equal to 5, this function will not be there. This function is there, so height is 2 plus this function we don't know. We don't know whether this function is present or not. Why? The problem is we don't know about k2. So we don't know from which point this will start. Okay. So let's leave it for the time being. Let's leave it. But this function will start at t equal to 2. If it starts at t equal to 2 and if it is on the right side, since it is on the right side, no, the coefficient of t is positive. So it is on the right side. So it will its height will be useful at t equal to 5. We have to use this height because at t equal to 5 this function is present. So it will be plus k0. Okay, plus k naught, and let's say this is also present, but it might be possible that this is not present because it depends on the k2 value. So if it is present at t equal to 5, let's say it is present, if it is present, then it will be plus 3, the height will be plus 3, okay. If this signal is present at t equal to 5, because it depends on k2 value, it depends on k2 value, okay. So if it is present, then I will say that the height will be 3, so I have to add 3 height, and it will become 7. Is it fine, guys? But there is one more possibility, and that possibility is, let's assume that this is not present at t equal to 5. If it is not present at t equal to 5, let's say k2 value came out to be minus of 14. Let's say k2 came out to be minus of 14. It means it will become t minus 7. T minus 7 means it will start from 7. It is not present at t equal to 5. So it might be possible that it is not present. So if it is not present at t equal to 5, then what you can do is, you can write this as 2 plus k naught only. 2 plus k naught equal to 7. So there can be two possibilities. One is this, one is this. It might be present at t equal to 5, or it may not be present at t equal to 5. Now let's come to the next. So I have told you there are two possibilities here, okay. From these two possibilities, k naught came out to be, from here you can see that k naught came out to be 2 and k naught came out to be 5, okay. K naught came out to be 2, k naught came out to be 5. If you look at the option, there is no 2 option. 2 is not given in any option. So let's eliminate it. Let's eliminate it. Because in any option, k naught equal to 2 is not provided. What does it mean? It means we have to take k naught as 5. K naught as 5. So this might be possible and this might be possible, okay. I hope you understood it. Is it fine, guys? Is it fine? So this might be possible and this might be possible because k naught is 5. K naught, and if you are applying this concept, what does it mean? It means k2 has to be greater than less than minus 10. K2 has to be less than minus 10. If you are applying this concept, if you are not taking this now, if you are not using this 3, what does it mean? It means that this function is not available at t equal to 5. This function is not, that's why you are not using its height. It means this function will start after t equal to 5. It means this has to be 3u of t. This has to be whatever this k2 by 2. This k2 by 2 has to be less than minus 5. It can be minus 6, minus 7, minus 8. Let's say it is minus 7. Then it will become u of t minus 7. It means it will start from 7 onwards. It will not be present at 5. Is it fine? So it means if you are using this concept, if you are applying, if your k naught is coming out from this expression, then you can say that k2 must be less than minus 10. From here you can say that k2 less than minus 10. So it means the option in which k2 is less than minus 10, that option will be correct. In the first option, you can see that k2 is 0. Okay, you can see that k2 is 0, so it cannot be the correct answer. D is correct answer. Only one answer is there. Okay, is it fine, guys? Only one answer is there. Okay, please try to understand this. K naught came out to be 2 and 5. There can be two possibility. Okay, there can be two possibility, whether you take this 3 or you don't take this 3, because k2 is unknown now. So there are two possibility. What are those possibility? It might be possible that this function is available at t equal to 5. So it might be, there might be one more possibility. So from here k naught came out to be 2, from here k naught came out to be from 2, and from here k naught came out to be 5. Now 2 is not given in any option. It means we have to select k naught is equal to 5. Okay, I think the first part is over. Now we need to come at the second part. Second part is we need to calculate the value of k2. How to calculate the value of k2? I told you this can be possible. You have to use this concept if this height is not utilized. If this height is not present at t equal to 5, then you don't take this height. Okay, what does it mean? If it is not present, it means this function k2 by 2 should be less than minus 5. It can be minus 6 or minus 7 or minus 8. Then you can say that it will not be present at t equal to 5. It will start from 6 or 7 or 8 or 10. but it is not present at 5. It means k2 by 2 has to be less than minus 5. Then only you will not consider this height. Otherwise, you have to consider this height. Okay, so I have done k2 by 2 less than minus 5. So k2 came out to be less than minus 10. Is it clear, guys? I hope it is clear. So k2 came out to be less than minus 10. So answer is Delhi. D option is correct. Okay. Let's proceed, guys. Let's come to the, okay, now what I want to do is I want to also tell you about the ramp function and the impulse function. Okay, so let's try to understand about little bit of ramp and impulse function. Okay, let me erase this part because I think it is I have completed this. Oh, okay, answer is Delhi. Now first let's look at the ramp and the impulse function. Okay, now let's look at the ramp and the impulse function. What is the ramp function? Ramp means slopey. Okay, ramp means the slope, RT. Okay, now RT means the slope is 1. The coefficient, now the coefficient will tell you about the slope. Okay, this is the coefficient, so it will tell you about the slope. So it will start from 0 because t equal to 0 is there. Okay, it will start from 0 and the slope will be 1. Okay, is it fine, guys? The slope is 1. It means in 1 second the height will be 1. Then only the slope will become 1. Is it fine? Now if I want to plot r of, let's say, minus 2t plus 3, how can you plot that? How can you plot that? R of minus 2t plus 3. Now remember, in this case what you need to do is, since the coefficient is negative, the coefficient of t is negative, it means this function will be on the left side. This function will be on the left side. Okay, from where this function start? This function will start, if you can put it like this, 2t plus 3 equal to 0, you can calculate the value of t, 3 by 2. It will start from 3 by 2. Now what you can do is you can take this 2 common out. In ramp function you have to take this 2 common out. In ut you don't use this a outside. Okay, you don't take this outside, a outside. Okay, because the scaling doesn't change the height of the function. But in this ramp function, the time scaling will change the slope of the function. That's why you have to take this out. Okay, so now you take this 2 out and it will be minus t plus 3 by 2. Okay, you have to write it like this. This is the function, guys. Okay, so whenever some function is given like this, you can simplify this. So if I need to, let's say this is k naught at plus b, then it will be equal to k naught into a r of t plus b by a. Is it fine, guys? But remember, a has to be positive. You can't take a negative. A has to be, that's why I have taken a equal to 2 only. In ut also a has to be positive. Okay, you don't take sign along with a. Okay, so a has to be positive. So leave this minus sign and take this 2 out and it will be like this. Now what is the slope of this function? What is the slope of this function? Because it's a ramp function, so we need to calculate the slope. The slope is minus 2. Why minus 2? The coefficient is 2 and the coefficient of t is minus 1. So you need to multiply for the slope. Okay, you need to multiply the coefficient of t and the outside coefficient. Okay, then only you will get the slope. So slope is minus 2. Is it fine, guys? Slope is minus 2. Is it clear, guys? Tell me. So slope is equal to minus 2. So you'll get the slope as minus 2. Now how to plot this function? To plot this function, it's very easy. Since the coefficient of t is negative, it means it will be on the left side. It will be on the left side. It will start from 3 by 2. Okay, so 0, this is 1, this is 2. So it will start from 3 by 2. Is it fine? It will be on the left side. It will start from 3 by 2. Since the slope is negative, it means it will be decreasing. It will be decreasing. Okay, that's why the slope will come out to be minus 2. Slope is minus 2, na? Okay, so it will be like this. Is it fine? It will be like this. Now the question is, what is this height? What is this height? You know that the slope is minus 2 and this length is 3 by 2. What is the meaning of slope? Slope means change in height divided by change in time. Now from this point to this point, if you look at this, from this point to this point, the time change, the change in time is 3 by 2 only. Because from 0, at this point the time is 0, at this point the time is 3 by 2. So you can say that the change in time is 3 by 2. I need to calculate the change in height. So from here you can say that the change in height came out to be minus 3. It means height is decreasing. How much height has decreased? Minus 3. At this point height is 0, so at this point height has to be 3. Okay, then only it will decrease by 3. So I hope you understood it, how to calculate the height. Tell me guys. Okay, I hope you understood it. So I told you how to tackle this ramp signal. Okay, and what are those formulas on a ramp signal you can apply. There is one more point. Whenever you get this ramp signal, you can say that this is, let's say I take a function like t, ft equal to t. Ft equal to t is some function. Okay, ft equal to t is some function. What can I do is, if you multiply this function with ut, okay, tut, what is the meaning of this? If you multiply these two signals, then it means if you multiply these two signals, the product will be after t equal to 0. The product, if you multiply it with ut, what does it mean? It means before t equal to 0, this is 0. Okay, after t equal to 0, it is t only, because this height is 1. So 1 into t is t only. So you can see that this is t only after t equal to 0, and before t equal to 0 it is 0. So you can say that RT can be written as TUT. RT can also be written as TUT. I hope you understood. Okay, so this way you can write the ramp signal. Okay, so I told you about the ramp signal. Now let's come to this question. No, this question is not based on ramp. Okay, let's come to the impulse signal. Okay, let's come to the impulse signal, because I told you about the basic part of the ramp signal and those important parts of the ramp signal. Okay, now I want to come to the impulse signal. Okay, so let's come to the impulse signal, guys. Let me remove it. Okay, let me erase this. Okay, let's come to the or let me erase the entire screen. Okay, because I don't have the blank screen, that's why I must have added some blank screen. Anyway, let's come to the impulse signal. Okay, impulse signal. Impulse signal is again very important. Impulse signal. I have taken some questions on impulse signals also. So I have taken some question. Those who have studied impulse signal very well, please try to solve this question. Okay, try to solve this question, or let me teach you about impulse signal on this screen on itself. Impulse signal. Okay, what is the meaning of impulse? This is the most important signal in signal and system. Okay, impulse signal. Direct delta function. You can also write it delta t. You can also write it delta t. Okay, now how to solve it? What are the properties of delta t? First of all, look at the definition of delta t. What is the definition? The height of delta t is infinite. Height of delta t is infinite. Okay, height of delta t is infinite at t equal to 0. Okay, it means its height is very large, infinite at t equal to 0. And the area of the delta t, area of function, okay, area of function came out to be 1. The coefficient will tell you about the area now. The coefficient will tell you about the area now. Okay, so area will come equal to 1. Now if you are looking at t equal to 0, the height is infinite. But if you are looking this impulse function other than t equal to 0, then the value of this function will be 0. Okay, so you can plot it like this. At t equal to 0, you will see the infinite height. Okay, and the area is 1. This 1 is not height, this 1 represent area. Okay, this 1 represent area, and it exists at t equal to 0. Other than t equal to 0, if you look at this side or this side, then this function will be 0. So you have to remember what is the definition of delta t. Now there are some basic concepts, basic properties of delta t. What are those properties? First of all, I want to tell you about del of 2t or kt or at simply. Del of at. What is the meaning of it? What I have done is I have scaled it with a. If you scale this function with a, whenever you scale any function, the area will change. The area of the function will change. Let me tell you how. Let's say you have a function like this. Let's say you have a function like this, 0 to 1, and the height is 2. This is my ft signal, and I need to calculate the area of this function. Please tell me the area. So the area came out to be 2. Now what I'm doing is I'm scaling this function. I want to plot f of 2t. Now tell me guys, if you want to plot f of 2t, the height will remain same. This will be divided with 2. This will also be divided with 2. So it will become 0, and this point will become half. Is it fine? So you have to plot it like this. Clear? So this will be f of 2t. Okay. Now what is the area of this? Area came out to be 1. Now you can see that the area will be decreased by the same factor, 2. It means whatever the factor is, let's say you take 2. So the area will be divided by 2. The new area of this function will be whatever the area of ft divided by the scaling factor. Is it fine? I hope you understood it. Now if you take minus 2 here, if you take f of minus 2t, then the area will remain same, only the function is flipped. So you can say that whether it is 2 or minus 2, it doesn't matter. You have to divide it with 2 only. So let's say you have function ft, its area is a0, and if you take f of 2t or minus 2t, whatever, or let's say f of at, okay, let's take f of at. If you take f of at, if you scale with a can be positive or negative number. If you scale with a, then the area will be equal to a0 divided by a mod. Okay, you have to take the mode of this function. Is it fine, guys? So I have told you how to simplify it, how to tackle the area. Okay, how to tackle the area of this function. Now if you know the area concept, if you know this area concept, okay, now you can understand f of del of at. Okay, now tell me, I told you what is delta t. Now I need to plot delta at, del at. Since you know that you have scaled this function, so if you have scaled this function, previously it was existing at t equal to 0, so it again, if you scale it with a, this point will become 0 by a. You know the time scaling. So this point will become 0 by a. 0 by a means 0. It will remain at 0. This function will also remain at 0. But an area, height of this function will again remain at infinite. Height will remain infinite. But the area, we know that the time scaling will change the area. It means the area will not be 1 now. It will become 1 by a mod. 1 by a mod. Is it fine, guys? I hope you understood it. Del of at. So you can write it like this. 1 by a mod del t. Okay, because the coefficient of delta t will represent you the area. Coefficient of delta t will represent you the area. Okay, so remember this point. Now let's take del of at plus b. At plus b. Now how to plot it? It's again very simple, shifting and scaling. So if you want to plot this, what you can do is, first of all you plot del of t plus b. Okay, del of t plus b, and then scale it. So del t is this. Now how to plot del of t plus b? You just shift it. You just shift it at minus b. So if you shift it at minus b, it will look like this. The area will become 1 and it will start at minus b. Okay, t equal to minus b. It will be advanced by b. Let's take b as positive number. Okay, now what I'm going to do is I'm going to scale it with a. So if you are going to scale it with a, it will be divided with a, and the area will not be 1 now. Area will be 1 by mod a. Is it fine? So the graph of this function can be represented like this. Now how to write it, how to simplify it? The simplification of this will be 1 by a mod, because it will be the new area, del of where it will exist, t plus b by a. Is it fine, guys? So you can write it like this. I hope you understood it. So whenever you have del of at plus b, you can write it like this: 1 upon a mod del of t plus b by a. Now remember, in ut function, in step function, you don't take a out. In ramp function, you take a out. But in ut and ramp, a has to be positive. But in this case, a you can take negative or positive. It doesn't matter. Let's say you want to write del of minus 2t plus 3. You can say that it can be a can be minus 2 here. A can be minus 2 here. And you have to take this minus 2 out. So 1 upon minus 2 mod. Minus 2 mod is 2. Del of t plus b by a. B is 3, a is minus 2. So it will become minus 3 by 2. Is it fine, guys? So you can simplify this like it. Okay, I hope you understood it. So it's simple. It's simple. How to simplify this impulse function, I told you. Okay, now there are some properties of impulse function. I told you how to write these impulse function. Now there are some properties of impulse function. What are those properties? So let's try to understand that and then try to solve this question. There are some students who have already given the answer. Okay, So please guys, if you can solve this question, it will be most welcome. Okay, so please try this. Those students who know how to tackle impulse function, please try to solve this question. Okay, so what we can do is we can get the properties. Let's say we multiply ft with delta t, then you know that it will become f of 0 delta t. Okay, I'm not going to prove it. Okay, ft into delta t is this, ft into delta t minus t naught, it will be f of t naught into delta t minus t naught. Okay, ft into del of at plus b. So first simplify this, you can say that ft into 1 upon a mod del of t plus b by a. Now what you can do is you put this t, you put it equal to 0 and calculate the value of t. So t came out to be minus b by a, put minus b by a inside this. So I'll get f of minus b by a into 1 upon a mod del of t plus b by a. So I'm not telling you how I have written this, how this is true. I'm not telling you, but just remember it, because it's not the right time to tell you about this. Okay, so if delta t is multiplied with some other function, then you can do it like this. I hope you understood it. Now whenever you have ft into delta t and you are finding the area of this function, you are finding the area of this function. Now what you can do is, you know the product, no? This product is f of 0 into delta t dt, and you need to take the area. You can see that the coefficient of delta t itself will represent the area. So answer is f of 0. Or what you can do is you directly calculate the t value. You put this t equal to 0 and you put this factor in equal to 0, the bracket, the inside bracket term. Okay, you put it equal to 0 and calculate the value of t and put that value of t here, and you will get the answer. Okay, so let's say you have f of t into delta minus 4t plus 2, okay, dt. You need to calculate this value. What is this value, guys? So what you can do is first you simplify this. If you can simplify it, you'll get f of t into 1 by 4 delta t minus 1 by 2. Is it fine? Is it fine, guys? Tell me. You can write it like this, from minus infinity to infinity. Now you put it equal to 0. If you put it equal to 0, t came out to be half. You can put t equal to half here. So the answer will be 1 by 4 f of half. Okay, this will be the answer. But while writing this, you have to be careful about the limit. This limit should contain this point, t equal to half. T equal to half should be in between the limits. Okay, let's say you are doing like this, f of t into del of minus 4t plus 2 dt, and the limit is from minus infinity to 0. What should be the answer? So in this situation, first of all you simplify it. It will become ft into 1 by 4 del t minus half dt. Is it fine, guys? Okay, you can write it like this, minus infinity to 2. Now you can see that this product will exist at t equal to half, but this limit is not including half point, because this limit is from minus infinity to 0 only. You are not coming at half. It means since you are calculating the area up to from minus infinity to 0 up to 0, you are not taking the area at half. So this has to be 0. Okay, because you are this product exists at t equal to half. So the area will also come at t equal to half. Before t equal to half, this function is 0. So the area will also be 0. Okay, so you have to be careful while writing. The limit is very important. So you have to be careful while solving this type of questions. Okay, so I hope you understood. There are so many properties of impulse function, but these are the important properties that you need to know for your GATE exam. But there are some more properties. Okay, there are some more properties like what is del of t plus a into t plus b. Okay, t plus b like this, and the derivative doublet function. Okay, I'm not going to tell you about those properties, because those are not important for the time being. So but you can if you want some extra edge, you can understand it, and you can search one video, important properties of impulse function by Asu Jangda. You will get those properties also. Now look at this question, guys. I want to solve this question. If you look at this question, then this question is first you open this function, no? So if you open this function, if you put k equal to 0 here, it will become delta t. If you put k equal to 1, it will become delta t minus t by 4 plus delta t minus t by 2 plus delta t minus 3t by 4. Fine. If you put k equal to 0 and then k equal to 1, 2, 3. Now similarly, you go on the left side, okay? You put k equal to minus 1. If you put k equal to minus 1, it will become like this, t plus t by 4. If you put k equal to minus 2, it will become t plus t by 2. And if you put k equal to minus 3, it will become t plus 3t by 4. Is it fine, guys? So this way you can write like this, the summation term, you can write like this. Multiply by, you have to multiply it with a sine of pi t by capital T, okay? You have to multiply it with this, and then dt, and then you need to take the area from minus infinity to infinity. Now we need to look at the product, okay? Delta t into this function, one by one we can do it now. Delta t into this function, tell me what is the value, and you have to take integration. You can separate out all these integrations, huh? 1, 2, 3, 4, 5, 6, 7 terms are there, so you can separate out each function, okay? So this function, if you take it out, it will become delta t into sine of pi t by pi t into t dt, okay? Let's say we need to calculate this one first. So you put t equal to 0 in this function and you will get the answer. So if you put t equal to 0 here, answer is 0. So because of this function, answer is 0. Now let's come to t by 4, okay? So you put t equal to t by 4 in this function, and you will the answer will be, if you take only this function, na, delta t, del of t minus t by 4 into this, and take the integration. So the answer came out to be sine of pi by t into t by 4 into t by 4. Is it fine? So this is cancelled, so you'll get sine pi by 4. From here you can see that you'll get the answer sine pi by 4, okay? And now you put this. So if you take this function, you have to put t equal to minus t by 4 in this function. If you put t equal to minus t by 4, then it will become sine of minus pi by 4, because you put t equal to minus t by 4. So it will become minus pi by 4, and these two values are opposite to one another, so the summation will be 0. So using these two functions, this will give you positive value, this will give you negative value, so it will be 0. Similarly, this will give you positive value, this will give you negative value, okay? So I have to cancel it. Now let's come to this point. If you put this t equal to 3t by 4, it will become sine of 3 pi by 4. Is it fine? Sine of 3 pi by 4. And you put t equal to minus 3t by 4, it will become sine of minus 3 pi by 4. Is it clear, guys? Tell me. Is it clear? So this is in second quadrant. In second quadrant it is positive and it is negative, because this negative will come out, okay? So it will become negative. So again they are opposite to one another and they will cancel. Answer is 0, okay? Answer came out to be 0. Is it fine, guys? Answer came out to be 0. I hope you understood how to tackle the impulse function, okay? So these those three functions are very important. Now let's take one more function. Yes. Now let's try to solve this question. Do it, guys. Do it fast. Let's try to solve this question. Again, this is based on the same property. Tell me, guys, what should be the answer of this question? Do it fast. Do it fast. Let's see how many of you can solve it. Do it fast. This is again very good question. Do it fast, guys. Do it fast. What is this? We have to take derivative of signum of sine pi by 80. First you have to plot this signum function, and then you have to take the derivative, and then you have to take the area. But the limit is 0 to t. Remember, the limit is 0 to t. Okay. So how to simplify it? First of all, let's plot a signum of sine pi by 80. Now the problem is how to plot this signum of sine pi by 80. We know that whenever you have signum t, the graph will be like this. It will be 1 here on this side and -1 here on this side. Is it fine, guys? Is it fine? It means signum t is equal to 1 for t greater than 0. It will be -1 for t less than 0. and 0 at t equal to 0. At t equal to 0, though it's not defined, but we'll take the average value because there is a jump discontinuity. So you can take the average value. So at t equal to 0, it will be 0. You can write it equal to 0 at t equal to 0. Okay. Now let's come to this function. So it will be 1 if this inside value sine of pi by 80 is greater than 0. It will be minus 1 if sine of pi by 80 is less than 0. It's simple. It's like this only, na? Previously it was t here. Now it is sine pi by 80. Okay. So I have applied the concept on sine pi by 80. Same concept. And equal to 0 if sine pi by 80 is equal to 0. So what you need to do is, first you need to plot sine pi by 80. Once you get this sine pi by 80, then you can check in which range it is positive, in which range it is negative, and you can plot this graph. So first I need to plot this graph. So let's plot. First of all, we need to plot the sine of pi by 80. How to plot the sine pi by of 80? Tell me guys, it's a sinusoidal function. So you can plot it like this. Tell me guys. You can plot it like this. Fine. Tell me. Now look at the instants, because the instants are important. Now you can see that this is 0. At this, it has to be pi. To make it pi, t has to be 8. So at this t has to be 8. At this t has to be 16, and at this t has to be 24. Is it fine, guys? It is minus 8. So we have plotted sine of pi by 80. Okay, we have plotted sine of pi by 80. But we are not interested in sine of pi by 80. We are interested in signum of sine of pi by 80. Wherever this signum t, whenever this sine of pi by 80 is positive, the signum value came out to be 1. Okay. So if I want to plot the signum function, if I want to plot the signum of sine of pi by 80, from 0 to 8, you can see that from 0 to 8, height must be 1. Okay. From 0 to 1, height must be 1. From 0 to 8, height must be 1, because the sine pi by 80 is positive. Now from 8 to 16, height must be minus 1. Is it fine? Height must be minus 1. And then it will be plus 1 from 16 to 24. And then it will be minus 1. Okay. Similarly on negative side. Is it fine, guys? So this way you can plot signum of sine of pi by 80. I hope you understood it. So we have plotted signum of sine of pi by 80. I told you how to plot the signum t, and then you can easily plot it like this. Now we have to take the derivative of this function. How to take the derivative of this function? If you need to take the derivative of d by dt of signum of sine of pi by 80. Now how to take the derivative, guys? To take the derivative, you can see that at the jump discontinuity you have impulses. Okay, because between them there is no change in height, so derivative will be 0. Okay, but at t equal to 0 you will get impulse function. Since you are going from minus 1 to 1, so height is changing from minus 1 to 1, it means height is changed by 2. So that 2 will become area. That 2 will become area. Here you will get the impulse. It means the height is infinite. The derivative will be infinite height, but the area of the derivative will be 2. So you will get an impulse here with area equal to 2. Here at t equal to 8, you will get area equal to minus 2. Okay. Then at t equal to 16, again the area is plus 2 and then minus 2. Okay. So this will be the derivative, guys. This will be the derivative. Okay. 24. Okay. And then 32. I hope you understood it. Now similarly on the negative side. Okay. Here you will get negative and then positive. Okay. So we have plotted this function. Now what I need to do is, I need to multiply this function with this half of t. But look at the integration. It starts from 0. It means we have to take these impulses only. Why? Why not the negative impulses? Because the limit starts from 0 itself. If the limit starts from 0 itself, it means we have to consider the product. This product, we have to look at the product which is after 0. 0 or maybe after 0. At 0 or maybe after 0. Okay. Only those values we have to check. So if you are looking these impulses, now before 0 impulses, the product will also be before 0. We will not consider that because the limit is stopping us going negative, going on the negative sides. That's why we'll look at the impulses which are starting from 0 onward. So you can say that this is 2 delta t. So what you can do is you can write this function as 1 by 2t. You can write it 1 by 2t, 2 raised to the power t into, this is 2 delta t minus 2 delta t minus 8 plus 2 delta t minus 16 minus 2 delta and so on. Okay, and so on. Now we need to multiply it and we need to integrate it from 0 to infinity. Now you will see that the first product, take this 2 out now from every values, take this 2 out. Oh, no, I did a mistake here. Wait a minute, you can't cancel this now. But what you can do is you can take this 2 out now. So tell me, what is this product, guys? So it will be 2 into 1 by 2 raised to the power 0 plus, rather minus, okay, minus 2 into 1 by 2 raised to the power 8 plus 2 into 1 by 2 raised to the power 16. Is it fine? Look, I have done this 2 delta t multiplied with this now. So 2 I have taken common and then put t equal to 0 in this. So you'll get this. And then I have taken this minus 2 out and then put t equal to 8 in this expression. So you'll get like this. So it will become a GP. It will become a GP. Is it fine, guys? Now you can solve it. You can solve this GP. It will become a GP. Now you can solve this GP. Is it fine? You can take this 2 common. So if I take this 2 common out, it will be 1 here minus 1 by 2 raised to the power 8 plus 1 by 2 raised to the power 16 minus 1 by 2 raised to the power 24 and so on. Okay. So it's a GP and the answer will be 2 into first term divided by 1 minus common ratio. So common ratio is second term by first term. Second term is negative, minus 1 by 2 raised to the power 8. Okay, this is my common ratio R. Okay, this minus has to be outside. This minus has to be outside the bracket. So this will be my GP. Okay, this will be my GP. So the answer came out to be 2 divided by 1 plus 1 by 2 raised to the power 8. So approximate answer came out to be 2 only. Okay. So you can solve it like this. I hope you understood it. Is it fine, guys? Okay, so this way you can solve this question. This is again very good question and it will become a GP. Okay, it will become a GP and you can solve the GP. Okay, so I told you about the impulse signal and the Signum function. Okay, I have also told you about the Signum function. Now, almost okay. Let's come to the next thing. And next thing is, so I told you about the singularity functions. I told you about the shifting and the scaling of the function. Now, I want to tell you about the type of the signals. So, type of the signals. So, signal can be of many types. We categorize the signal. Let's come to type of the signals. Type of the signals. So, let me write it here in this expression. Type of signal. Type of signals. What are the type of signals? Tell me, guys. What are the type of signals? Signal can be of periodic, aperiodic, periodic, aperiodic, okay, and then energy, even odd, even and odd. Number 3, energy and power, causal and non-causal, causal and non-causal, continuous and discontinuous. Okay, these are the characteristics, causal and non-causal. Anyway, so mainly we'll look at the four things. Okay, periodic, aperiodic, even, odd, energy and power, and causal and non-causal. So let's first discuss about periodic and aperiodic. So I have taken one question on this. This is the question, guys. We need to calculate the period of this, deterministic and non-deterministic. Yes, obviously. Okay. So please tell me about the answer of this question. Please tell me the answer of this question. I need to calculate the period of this function. What is the period of this function? Now remember, the mode is applied. Okay. Whenever you apply the mode, things will change. Okay. So please tell me what should be the period of this signal. Tell me, guys. And those students who haven't liked this session, please do like this session, guys. Okay. This is important. Please like the session. Those students who haven't liked this session, please like it. So tell me guys, what should be the period of this signal? Do it fast. What should be the period? Do it fast guys. This is important. This is important. Wherever you get the mode, then things will change. Things will change. What is the period of this function? Can you tell me? What is the period of this mode of sine 2t? Mode of sine 2t. First of all, you calculate the period of sine 2t. The period of sine 2t is 2 pi by omega, 2 pi by 2. Okay. So it came out to be pi. If the period of sine 2t is pi, what is the period of sine 2t mode? Tell me guys, what is the period of sine 2t mode? If you take the, look, the graph of sine 2t is this. The graph of sine 2t is this. So period is pi. Okay, sine 2t is this. So period is pi. But if you take the mode, mode means you have to rectify the signal. If you rectify it, if you take the mode, then the period will change. Period will become half. Okay, so in this case, the period is pi by 2. Is it fine guys? Tell me, have you understood this point? Say yes or no. So it will be pi by 2. So the period of this function is pi by 2. Now, let's come to this question. Let's come to this question. I mean, this part is over. Period is pi by 2. Period is pi by 2. But remember, whenever you take the mode of any signal, it doesn't mean that every time the period will get half. No. Let's say, let's take a function like this. Let's say I have a function like this. Okay, I have a function like this. Now tell me the period of this function. 0, pi, 2 pi, 3 pi and 4 pi, and then again it will start like this. Okay, now tell me what is the period of this function. Can you tell me? What is the period of this function? Tell me guys, what is the period of this function? Tell me. The period of this function is 2 pi. You can see that the period is 2 pi. Period is 2 pi. After 2 pi it's repeating. That's why the period is 2 pi. But if you take the mode of this signal, if you take the mode of this signal, tell me the period. If you take the mode of this signal, the period will again remain 2 pi. It will not be pi. If you take the mode, it will look like this. And then up to this, it will look like this. And then 0. Okay. And then, so it will be like this. Now you can see that this is 2 pi here. Okay. This is pi here. This is 3 pi and this is 4 pi. So now you can see that what is the period? The period came out to be 2 pi only. Okay. Again the period is 2 pi. So it doesn't mean that every time you take the mode and the period will get half. No, it's not like this. How to check? How to check whether the period is becoming half or not? Whenever you take the mode, then the period will become half or not. How to check it? Because sometime it will become half. I mean, whatever the period pi, it will become pi by 2. But at some situation, it will become, it will remain same. There are some situations in which the period will also become 1/4 of that. Let's say the period is pi here. If you take rectification, if you take the mode, it might be possible the period came out to be pi by 4. It might be possible. It means it's not necessary that every time it will be get halved or every time it will be 1/4. It's not necessary. Let me take one more example. Okay, let me take one more example. So be careful guys. Okay, be careful. You have to check. You have to check whether period is getting halved or not. Let's take one more example. Let's say I have a function like this. Let's say I have a function like this. Now, let's say 0, this is pi by 2. Let's not take it pi by 2. Let's take it pi. 0 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. Okay. Now tell me the period of this function. What is the period of this function, guys? You can see that this gap, this box is repeating again. So the period has to be 3 pi. Period has to be 3 pi. Okay. The period has to be 3 pi. Is it fine? Now, if you take the mode of this signal, tell me what will happen. If you take the mode of this signal, the signal will look like this. The signal will look like this. Fine? Now tell me the period. The period will be pi now. It's 1/3 of the previous period. Is it clear, guys? It's 1/3 of the previous period. It means if you are taking mode of any signal, it doesn't mean that period will become halved all the time. It may be 1/4, it may be 1/3, okay? It depends on the shape. Okay? So be careful while taking the mode. You have to be more careful, okay? Now how to check? Whether it is getting 1/3 or 1/4 or halved, okay? So it's a tedious process, okay? So let me tell you, in this case, it was easy. Why it was easy? Because we know the wave shape. You know the wave shape of this function. So if you take the mode, you'll get to know that period will become pi by 2. But in this case, we don't know about the wave shape, okay? Now it will be a challenging part. Let's see. Now we can't do anything. We have to apply hit and trial method, okay? First of all, please tell me what is the period of this function without mode. 2 cos of 1 by 2t plus 3 sine of 3t. Okay, what is the period of this function? First of all, let's take without mode function. Okay, we need to calculate the period of this function. What is the period of this function, guys? It will be 4 pi here, 4 pi upon 1, 2 pi upon half. 2 pi upon half is 4 pi, and here it will be 2 pi by 3. Tell me, guys. The period of this function is 4 pi upon 1. The period of this function is 2 pi by 3. So now what you need to do is you need to take LCM of the numerator and HCF of the denominator. So HCF of the denominator is 1 and the LCM of the numerator is 4 pi. So overall period came out to be 4 pi by 1. Overall period came out to be 4 pi by 1. For this function, it's 4 pi. Now the question is, if I take the mode, will it get halved? Will it get 2 pi? Or will it get maybe 1/4 or maybe, will it get change? Question is this. How to check it? The way to check it is, we can't do it. There is a hit and trial method. We can't solve it, okay? So the problem is, let's see whether it will be halved or not. So what you can do is, you can take any t value. Let's say you put t equal to pi by 4. And then you put t equal to pi by 4 plus 2 pi. You check the value at t equal to pi by 4 and then pi by 4 plus 2 pi. Okay, pi by 4 and then pi by 4 plus 2 pi. If the value of this function is repeating, it means the period is 2 pi now. So it's a rough idea I'm telling you, okay? It's a rough idea I'm telling you. There may be some method. I have developed some method in one class. I don't remember that method, but anyway, you can apply this method, and then only you can tell me the answer. Now tell me, if you put t equal to pi by 4 or maybe pi by 2, let's take it pi by 2. No problem with pi by 2. Let's take it pi by 2. I want to take t equal to pi by 2, and then I want to check at t equal to pi by 2 plus 2 pi whether it is repeating or non-repeating. So because I want to check whether period is 2 pi or not, whether it get halved or not. Okay. Now how to check it? There is one more way. If somehow you can plot the wave shape, because there are you can see that it's a superposition of two signals. Okay. So what you can do is somehow you plot this signal. Let's say I plot this signal. So if I plot this signal, it will become cosine wave. It will be a cosine wave. Okay. And you can plot this signal also, and you get the ideas of the points. You can add it and you get the ideas of the point and then take mode. Then again you can check it. Otherwise, what you can do is, I told you the overall period is 4 pi without mode. Let's take it half. Okay, let's take it half. It will become 2 pi. Now if it is 2 pi, first we have to check whether the period is 2 pi or not. So what you can do is you can calculate the value at t equal to pi by 2, and then you calculate the value at pi by 2 plus 2 pi. Okay, if it came out to be equal, then the period will become 2 pi. Further you check, take half of that, pi. Okay, it might be possible that the period came out to be pi itself. Okay, so you have to check the period pi again. So this way you can calculate the period, otherwise it will be very difficult. It will be very difficult to solve, okay? Once you get the period of this, then it will be easy to solve the overall period of the two functions. So you have to calculate the period of this function. Now I'm not completing this because it's a lengthy process. I think the period is 2 pi. I think the period of this function is 2 pi. Please check it. I'm not sure that, but I have told you what is the problem here, okay? So you have to be careful. You have to check only by this method. So let's try this. Let's give it a try. So it will be 2 cos of, if you put t equal to pi by 2, it will become pi by 4 plus 3 sine of, if you put t equal to pi by 2, it will become 3 pi by 2. So the value came out to be, 3 here, oh, no, minus 3 here. 3 pi by 2 is minus 3. Minus 3 here and 2 by root 2 here, okay? So this will be the value at pi by 2. Now I want to calculate 2 pi plus pi by 2. So it will become 2 cos of 1 by 2 into 2 pi plus pi by 2, okay, plus 3 sine 3 into pi by 2 plus 2 pi, okay, and I need to calculate the mode of this. Is it fine? Now if you want to try this, what you can do is you can write it like this: 2 cos of pi plus pi by 4, and pi plus pi by 4 is in third quadrant, so it will be negative, so it will be minus 2 by root 2, okay, and look at this, it will become 3 sine of 6 pi plus 3 pi by 2, okay, 6 pi plus 3 pi by 2, 6 pi is 0 and 3 pi by 2 is negative again, so it will be minus 3 again, okay. So this is the value, guys. So at t equal to pi by 2, this will be the value. At t equal to pi by 2 plus 2 pi, this will be the value. It means it's not repeating. It's not repeating at 2 pi. What does it mean? It means we have to take period as 4 pi. We have to take period as 4 pi. It's not getting halved. Is it fine? Sir, if positive half and negative half of the signal look like the same, then if we take mode, then the period, yes, that's correct. If the positive half and the negative half look like the same, and I mean the symmetric, okay, I have given you the example, 2-3 example before that. So if they look symmetric, then you can say that it will get halved or maybe 1/3 or, okay. But the problem is, for that you have to look at the wave shape. We don't know the wave shape of this function. That's the main problem. That's why what we are going to do is, obviously the period is 4 pi. 4 pi is for sure. It will remain 4 pi, okay, period will remain 4 pi. But it may be possible that the period will come out to be 2 pi or maybe pi or maybe, okay, whatever. So what we have done is, we have checked 2 pi. At pi by 2 we have calculated the value, and then pi by 2 plus 2 pi, I have checked the value. They are not repeating. It means the 2 pi cannot be the period. So let's take it 4 pi only. Is it fine, guys? 4 pi will be the period for sure. It may be possible that it is not the fundamental period. It may be possible that this is not the fundamental period. But it is for sure, it is period, okay, for sure it is the period of this function, okay, but it may not be fundamental period. Fundamental period will be maybe less than this value. But anyway, since we have halved it and we have checked it that it's not repeating, so we have taken the period as 4 pi only. Now what we are going to do is, we have to take the LCM of the numerator, it will be 4 pi, and HCM of the denominator as 1, okay. So the answer came out to be 4 pi by 1. Is it fine, guys? I don't think that we need to go for pi, because if 2 pi is not the period, pi will not be the period. You are taking further half of that. I don't think that this will work. Once this 2 pi is not the period, then don't take it half, okay. Stop it here. Only the 4 pi you can take, okay. So you can calculate like this. So this is again a very good question. Anyway, so I told you about the period and how to calculate the period, and I have taken one interesting problem, okay, the mode part. Anyway, let's come to the energy and power signal. So this is the question, guys. Tell me what should be the answer. Again, this is very good question. So two signal ft, gt and ht or nt, whatever, better write it ht, okay. So there are 3 signals, ft, gt and ht are even and odd, okay. This is even, this is odd, okay, respectively. And there is one more function, pt equal to ft minus gt minus ht, okay. There is one function given like this. Now, energy of ft, gt and ht are, energy of ft, gt and ht are 20 joule, 18 joule and 20, wait a minute, let me check the original file, because I have designed these questions. Okay, so it came out to be 15 joule. Wait a minute, no, 200 joule, that's correct. Okay, this is 200 joule respectively. Energy of FT, GT and HT 20, 18 and 200 joule respectively, and the energy of PT can be 30 joule. No, it cannot be 200, it can be 20. Okay, please correct it. Okay, it cannot be 200, it can be 20 joule. Okay, it can be 20 joule. Okay, so the energy came out to be, let's see whether it is wrong or maybe it might be correct, but we have to see. So it is 220 joule, 18 joule or 20 joule respectively, and the energy of PT is 30 joule. PT is given as 30 joule. Okay, the wave shape of FT and GT are shown. This is the wave shape of FT and this is the wave shape of GT. We need to calculate the K1 and K2 value. We need to calculate the value of K1 and K2. Okay, tell me guys, tell me. Yes, Marda, Monica Devi. Yes, that's what I'm telling you. If 2 pi is not the period, don't go for pi. Okay, don't take it further half. Okay, so now tell me guys, tell me what is the value of K1 and K2. The question is on your screen. PT is this function and the energy of FT, GT and HT are given. It is also given that FT is even, GT is even and HT is odd. Okay, and the energy of PT signal is 30 joule. Energy of this PT signal is 30 joule. We need to calculate the value of K1 and K2. How to calculate the value of K1 and K2? Okay, first of all, what is the energy of PT? The formula for energy of PT is, we need to take the PT square dt and from minus infinity to infinity. This will be the energy of PT. Fine. This will be the energy of PT. Is it clear guys? It should be from minus t to t and limit t tends to infinity. So I have put the value t as infinity. So it will be from minus infinity to infinity. This is the energy. Now if you put the value of PT square, so it will be FT square plus GT square plus GT square plus HT square. Tell me guys, HT square plus 2 times of FT GT plus 2 times of GT into HT plus 2 times of FT into HT. I hope it is clear. Tell me guys, is it clear or not? If I take the square of this function, if I take the square FT square plus GT square plus HT square plus 2 times of, it will be minus 2 times of. Wait a minute, I have to write minus here. Okay, wait a minute, because FT and GT have opposite sign, so it will be minus here, and then GT and HT have same sign, so it will be plus here, and then FT and GT also, FT and HT also have opposite sign, that's why minus here. Okay, so what I have done is I have squared it. Is it fine? I have squared the function FT square plus GT square plus HT square minus 2 times of FT into GT plus 2 times of GT into HT minus 2 times of GT into FT into HT. Okay, so I have calculated the energy of this function equal to this. What is this function? This is the energy of FT, this is the energy of GT, and this is the energy of HT. So what we can do is energy E of PT must be equal to energy of FT. Energy of FT is, tell me, it's 20 joule plus what is this energy of GT, that is 18 joule plus energy of HT. HT is 20 joule. Okay, 20 joule minus 2 times of FT into GT. FT is even function, GT is also even function. So I have to write it like this, minus 2 times of, from minus infinity to infinity, FT into GT. Okay, FT into GT. Okay, because I don't know the value of this function, that's why I have put directly like this. Okay, plus 2 times of this. But if you look at this function, one is even, one is odd, so the product will be odd. If the product is odd, if you are taking integration from minus infinity to infinity, it will be 0. For odd function, if you are taking symmetric integration, it will be 0. Similarly, ft into ht. ft is even, ht is odd. So the even into odd function will be odd again, and the symmetric integration will be 0. So only this will be the energy. Now from here, you can see that energy, the total energy is 30 joule. Is it fine, guys? Because the energy of Pt is given as 30 joule. So E is given as 30. So from here, I can say that integration from minus infinity to infinity, ft into gt into dt, okay? If you want to calculate this value, it came out to be 30 minus 58 divided by 2, okay? So 30 minus 58 is minus 28 divided by 2, it will be 14. Is it fine, guys? Say yes or no. Is it fine? Tell me about this. Is it clear, guys? So what we have done is we have calculated ft into gt as minus 14. I hope it is clear to everyone. So the area of this product has to be 14. Area of this product has to be 14. Now we need to calculate the value of k1 and k2. How to calculate the value of k1 and k2? First of all, energy of this function is given as 18 joule. Energy of this function is given as 18 joule. So what we can do is we can calculate the energy of this signal. How to calculate the energy of this signal? Let me write the energy of this signal first. So we want to calculate the energy of this signal first, and that will be equal to 18 joule. So we can equate it to 18. So we will get one equation between k1 and k2. Okay, we'll get one equation between k1 and k2. And then you have to take the product of these two signal, and the area of the product of these two signal will be 14. Okay, so this way you'll get two equations. You'll get two equations and you can calculate the k1 and k2 value. I hope you get the idea. Now you can solve it yourself. Okay, now you can solve it yourself, guys. Let me repeat this again. The first thing is energy of gt is given as 18. So what we have done is we have calculated the energy here. So energy will be in terms of k1 and k2. So you'll get the one equation from this relation. You calculate the energy of gt, that must be equal to 18. Now you'll get the relation between k1 and k2. You'll get one equation. Now you take the product of ft and gt and take the area of that product. Area of that product has to be 14. So that from this product relation, you'll get one more equation between k1 and k2, and this way you can calculate the value of k1 and k2. This is lengthy question, but I told you the process. Okay, I told you the process how to solve this question. I hope it is clear to everyone. Let's move to the next question. Next question is again very important. Now it's an objective question, so everybody can try this question, and it will take less time. Okay, so please try to solve this question, guys. Please draw the resultant wave shape. Okay, what you can do is if you multiply them, then you can plot the resultant wave shape like this. Let me draw the resultant wave shape. 0, 1, 2, -1 and -2. Okay, now between 0 and 1, this is constant k1 and this is increasing. It has some slope. So the equation for this line is root 7.5t. Root 7.5t multiply by k1. Okay, so it will become, again it will be a slopy line, but now the slope will change. Okay, it will be multiplied with k1, so the slope will become root 7.5 k1 into t. This will be the line. So at t equal to 1, the height will become root 7.5 into k1. Is it fine, guys? Now from 1 to 2, if you look at 1 to 2, from 1 to 2 it is root 7.5 and it is k2. So if you multiply it, the height will be somewhat different. Okay, let me plot it like this. Okay, so the height will become, or maybe it will be upward. You have to show it upward. Okay, so now what you can do is after this point it will become like this, and the height will become root 7.5 into k2. Is it fine, guys? So this way you can multiply them. Now since this is even, this is also even, so the product will also be even. On this side also it will repeat. Okay, so this is the product, this is the wave shape of the product. I hope you can do it now. Okay, now let's come to the next question, guys. Again, this is very good question. Do it fast. Do it fast, guys, because now I want to switch to system. So there is one more question here. Please do it fast. Tell me what should be the answer. There are three signals, ft, gt and ht. ft, gt and ht. Energy of, this is not every, energy of ft, gt and ht are, FT, energy of GT, FT, GT and HT are 10 joule, 20 joule and 15 joule respectively. Energy of PT, PT is given as FT plus GT plus HT, okay? It's 45. It is the sum of these three values, 10 plus 20 plus 15. It will become 45. So now PT is the sum of these three signals and energy is also getting added, okay? Only if, now tell me, the energy of HT came out to be 45. It means it's the sum of energy of FT plus GT plus HT. Now, how can you get the sum? Which option is correct? Tell me guys, which option is correct? Tell me everyone, which option is correct? Which option is correct? Tell me everyone. Answer is, okay, let's calculate the energy of PT. So the energy of PT is PT square. This is the energy of PT, fine. Now if you calculate the energy of PT, how you'll write like this? It will be, if you take the square of this, it will be equal to FT square plus, you take the square of this, no? Plus GT square plus HT square plus 2 times of FT into GT, FT into GT plus 2 times of GT into HT plus 2 times of FT into HT. FT into HT. Is it clear guys? So this way we can write the energy. Now this is the energy of FT, that is 10. This is the energy of GT, that is 15, and this is the energy of HT, that is 20. Okay, wait a minute. 10, this is 20, okay, and this is 15. Okay, now this has to be 0, this has to be 0, and this has to be 0. Only if, only then energy of PT will be equal to sum of the individual energy. Okay, this has to be 0, this has to be 0, this has to be 0. It means the product has to be 0. If you take product of any two signal, it has to be 0 or it has to be odd. Then only you will get 0 here and 0 here. Let's say this is odd function, so the symmetric integration will be 0. Let's say this is odd signal, symmetric integration is 0, and this is odd signal, symmetric integration. Now you can't have all the odd signals. Let's say there are some students that think that, sir, if I take all the odd signals, let's say all the 3 signals are odd. If FT and GT are odd, then the product will become even. So you can't take it 0. Okay, so that's the main problem. So this option is wrong. You can't take all odd signals. And the B option is also not true, because so look at the C option. Any one must be odd signal and other must be even. Or only one signal if you take odd and the other you take even, then again this is not correct, because this is odd, this is even, this is even. So the product of these two signals will remain even, because this is even, this is even. So GT into HT will remain even. Okay, GT into HT will remain even, and it will not be 0 then. I hope it is clear. So again, this cannot be true. Now the D option, product of any two signal either must be odd or 0. That's correct. Either the product of two signal is odd or it is 0. Then only you can say that. So answer is Delhi. Answer is Delhi. Okay, D answer is correct. I hope you understood it. Now let's come to the next question. Yes, this is now discrete signal. Let me tell you guys, there are some properties on energy. There are some properties on energy, and you can apply the properties on energy. What are the properties? Let's say you have FT signal and the energy of FT signal is E. What is the energy on F of AT signal? What is the energy of F of AT? It will be E upon mod A. E upon mod A. Okay, remember like this. Energy. And what is the energy of AFT? What is the energy of AFT? It will become A square E. Okay, if you multiply the coefficient with A, the energy will become A square into E. If you do this time scaling like this, then the energy will become E upon mod A. Okay, so I hope you understood how to take what are the rules on energy. But let me tell you guys, in discrete signal these rules are not applicable. Let's say you have Fn signal and the energy is E. Okay, energy of this Fn signal is E. Now tell me, if I take F of half n, what is the energy of this signal? Energy of this signal will also remain E. It will not change. What is the energy of f of 2n? Energy of f of 2n may or may not be less than E. It may be equal to E or less than equal to E. But you can't apply this rule. You can't apply the same rule. It may be equal to or less than E. Okay. It depends on the number of samples. Whenever you take half of n, then samples will remain same. Only the distance between the samples will increase. Okay. So the energy will remain same E, because the number of samples are same and the height of the samples is also same. That's why the energy will remain E. But if you take 2n, if you scale the Fn with 2, then it might be possible that some samples will go, okay, some samples will disappear. So the energy will become less than E, okay. I hope you understood it. So those students who have studied discrete signals, they can easily connect with this relation, okay. So please be careful. If Fn has energy E, and if I multiply with k naught Fn, the energy will become k naught square into E, okay. So please be careful. In discrete signal, you have to be more careful about the energy. Okay, now let's look at this question. A signal Fn is shown below. So a signal Fn is given as y naught minus 2, 1, x naught, y naught and 4. Let me check the original file from where I have made this question. Okay, and the arrow is not given. The origin is not provided to you. Okay, the energy of the signal f of 1 by 3 n minus 10 is 25. It is given that the energy of this signal is 25 and the energy of odd part of the signal is 16 joule. Find the energy of f of 2n minus 10. We need to calculate energy of 2n minus 10. How to calculate the energy of 2n minus 10? Look, shifting does not change energy. Remember this point, shifting does not change energy. So if you look at this f of 1 by 3n, now tell me how to plot this function. To plot this function, first you need to plot f of n minus 10. It means what you are doing is you are shifting the signal. Fn is given as this, you are shifting the signal. If you are shifting the signal, energy will not change. Similarly, if you are multiplying with 1 by 3, it means no sample will disappear. Since you are scaling with 1 by 3 factor, so the distance between the samples will increase to 3 times. Let's say Fn is like this, now. Let's say Fn is like this, simple. Let's take it like this. Fn is like this. So if you're scaling it with 1 by 3, if you want to plot f of 1 by 3n, then what will happen, guys? These samples, I mean the distance between the samples will increase. 0 will remain at 0, 1 will go to 3, 2 will go to 6, okay. So I hope you understood it, how the distance will increase, okay. So if you scale it with 1 by 3, distance will increase, but the sample will remain same. It means the energy will remain same. So first of all, what you have done is you have plotted n minus 10, so energy will remain E, and then you scale it with 1 by 3, energy will again remain same E. It means the energy of this signal is same as the energy of Fn. So with this relation, I can say that energy of this signal came out to be 25. Now what is the energy of this signal? How to write the energy of this signal? What you can do is you can square the sample and add it. So if you take the square of the sample, it will become y naught square plus it will become 4 plus it will become 1 x naught square, okay, plus y naught square plus 16, okay. This is the energy of this signal and it came out to be 25. Now you'll ask me, sir, why it is 25? Energy of this signal is 25. So I told you the energy of this signal will remain as the energy of Fn, because in this signal I am shifting and I am scaling. Shifted by 10, shifting does not change energy, and scaling with 1/3, 1 by 3. So if you are scaling with 1 by 3, the sample will not disappear. Every sample will remain in the signal. So you can say that the energy will remain same, okay. So I hope you understood it. It's similar to this case, okay. So now you can see that this is the relation. So it will be 5 plus 16 is 21. So 21 plus x naught square plus 2 y naught square came out to be 25, okay. So from here I can say that x naught square plus 2 y naught square is equal to 4. Is it clear, guys? Is it clear? So from here I get this relation. Now the next thing is energy of odd part of Fn is 16. Okay, energy of odd part of Fn is 16. What is the odd part of this signal? What is the odd part of this signal? Okay, we need to calculate the odd part. Let's say the origin, because arrow is not given, so I can assume that the origin is here. Okay, origin is here. So before going to the origin, let's come to this. Okay. The energy of the odd part of the Fn is 16. It is given that the odd part energy is 16. So how to calculate the odd part of this signal? What I need to do is, I need to take the arrow as at this point. I mean, this is the 0 point. How to calculate the odd part? The odd part of the signal Fn odd can be represented as Fn minus f of minus n divided by 2. Is it fine? So it will be equal to, at this point it will become 0. Okay, so the odd part, let me write the odd part. So at origin it will become 0. Okay, now it will become minus 1, it will become half, because on the positive side you have only this side, this part. On the negative side you flip it on the negative side. Okay, so what you can do is, you can say that it will be 0 minus 1. If you calculate the odd part, 0 minus 1, that is half, and it will be x naught by 2, and it will be y naught by 4, y naught by 2, and it will be 2. Okay, so this is the positive side. Now what about the negative side? Negative side will be opposite to that. It will be 1 here, and then minus half, and then minus x naught by 2, and then minus y naught by 2, just opposite to that, and it will become minus 2. Okay, it will become minus 2. So this will be the odd part, guys. What I have done is, I have calculated the odd part also, and the energy of this odd part came out to be 16 joule. Energy of this odd part came out to be 16 joule. Okay, now what you can do is, you can make one more relation with x naught and y naught. Okay, there will be one more relation with x naught and y naught. What is the energy of this signal? Let me calculate the energy. It will be 0 plus 1, I have taken the square of this, plus 1 by 4, plus x naught square by 4, plus y naught square by 4, plus 4. Okay, this is the energy of this side, and the energy of this side will remain same, so I double it. Okay, I double it. This came out to be 16. It is given as, this is 16. Now if it is 16, then what you can do is, you can simplify this and calculate the value of x naught and y naught. There is one more relation you will get between x naught and y naught. Okay, now how to solve it? Let's take 4 as LCM. So if you take 4 as LCM, okay, take 4 as LCM, so it will be 16 plus 1, 4 plus 1 is 5, so 5 into 4 is 20, plus 1 plus x naught square plus y naught square. Okay, is it fine, guys? Equal to 16. Now what you can do is, you can cancel this with 2 and take this on this side, so it will be 32. 32 minus 21, 32 minus 21 is 11. Okay, so x naught square plus y naught square came out to be 11 from here. Is it fine, guys? X naught square plus, I don't think that this is correct. Wait a minute, let's check whether I have done some mistake or not. It is 5, take LCM as 4, so 20 plus 1 plus this, I think this is correct, into 2, okay, and it came out to be 16. Okay, so I have cancelled it with 2, so it will become 32. 32 minus 21 is 11. So x naught square plus y naught square came out to be 11. I think there is a mistake in this question. Okay, I think there is a mistake in this question. It cannot be 16. It cannot be 16. Okay, it has to be less than 16. It has to be less than 16. Let's change it. Let's change it and let's make it 12. Let's make it 12. Okay, let's make it 12. Let's make it 12. If it is 12, then on this side you have to put 12. On this side you have to put 12. So 12 into 2. This is 12 now. Okay. So 12 into 2 is 24. 24 minus 21 is 3. Now you will get 3 here. Is it fine, guys? Now you will have 3 here. So from here you can calculate x naught and y naught. There are two relations. Now you can calculate the x naught and y naught value. Is it fine? You'll get x naught and y naught value. Once you get the x naught and y naught value, then you can calculate the energy of this. Okay. Now you can plot this function and calculate the energy of this function. I hope it is clear to everyone. Now you can solve it. You can first calculate x naught square and y naught square from these two relations. Once you get the x naught square and y naught square, then you can plot this signal. How to plot this signal? If you are shifting it n minus 10, if you are shifting it, it doesn't matter. Okay, energy will remain same. But you are scaling with 2. If you are scaling with 2, some sample will disappear. Which sample will disappear? Tell me, guys. First of all, you have to shift it to 10. Okay. Now, if you are shifting it to 10, then what will happen? This 0 point will go to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. 11, 12, 13, 14, 15, 16. Okay. This 0 sample will go to 10. This is y naught. Okay. This will be appear at 11. Okay. Minus 2. This will appear at 12. 1. This will appear at 13. X naught. Okay. And this will appear at 14. Y naught. Okay. And then this will appear at 15. Is it fine, guys? Now, if you divide it with 2, because you are scaling with 2, so some sample will disappear. This will disappear. This will also disappear. And this will also disappear. So, only sample which will be left behind is this y naught, 1 y naught. Only 3 sample will be there. So, the energy will be equal to y naught square plus 1 square is 1 plus y naught square. Okay, plus y naught square. So, you can see that 3 sample will disappear. Okay, because if you divide them by 2, they will become fractional. So, they will disappear. Only these 3 sample, y naught, 1 and y naught will remain. So, you can take y naught square plus 1 plus y naught square, 2 y naught square plus 1. Okay, 2 y naught square plus 1. And y naught square we can calculate from here. So, we can put it here and you can calculate the energy. Is it fine? It is 3 joule. Okay, that's correct. So, I told you how to calculate, how to solve this question. I hope you enjoyed. Anyway, let's come to the next thing. Now, I want to start with the system. Okay, now I want to start with the system. But since the time is not allowing me, because you can see that it's 11:50. So now what we can do is, let's stop it here, and Ankit Joshi sir will continue from this point onward in the next class, because there is one more class. Part 2 is also there. In part 2, what we are going to do is, we are going to study this type of system and then Fourier series and then Laplace transform. Because in the next 2 hours, because I'll get one more session. There are 2 sessions, 4 hours, 2 sessions. So 2 hours for me and then 2 hours for Ankit Joshi sir. So Ankit Joshi sir will join now, and let me tell you guys the type of system, and there are so many properties of LTI system. So we will discuss that in the next session. Okay. So in the next session I'll cover system and Fourier series and then Laplace transform. Okay. So these topics I'll cover in the next session. I hope you enjoyed today's class, guys. I hope you enjoyed. So let me contact to Ankit Joshi sir, and then you can start with Ankit Joshi sir. Okay. So give me some time so that Ankit Joshi sir can join. Till then, those students who haven't liked the session, please like it. Okay. So please like the session, guys. So let's wait, and let's Ankit Joshi sir, let me contact Ankit Joshi sir, and then I'll Okay, guys, so Ankit Joshi sir will join us after 10 minutes. So let me continue for 10 minutes. But till then, I want to ask you some questions. Till then I want to ask you some questions. Okay, let's see how many of you are able to solve these questions, because Ankit Joshi sir will come after 10 minutes, so maybe for 10 minutes I can continue. So there are some questions which I want to ask you, and I want you to tell me about those questions. So the first question is, let's say, okay, I have not told you about the system, but I assume that you have already studied systems. So please try to solve these questions which I am going to give you, and then if you are not able to solve these questions, I will discuss in the next session. Okay, so don't worry guys. So let's take one question. There is a series connection of two linear time invariant. Let's say we have LTI system A. There is LTI system A. Though I have not told you about LTI system, but I hope you know that you know this LTI system. What is LTI system? Okay, and there is a LTI system B. Now I want to know whether the series connection of two LTI system will remain LTI or not. Tell me guys. This is A, this is B. Let's call it this system as B, and they are connected in series, like in cascade form. Now whether the resultant, whether their equivalent will be LTI or it may not be LTI. Tell me guys, will it be LTI or it may not be LTI? Tell me guys, their equivalent, will it be LTI or it may not be LTI? Tell me everyone. If you are cascading two LTI system, then the resultant will be an LTI system or non-LTI system, or it may be LTI, may not be LTI. Tell me guys, tell me whether it will be LTI, the resultant will be LTI. Let me give you the option. A option, resultant system is LTI. B option, resultant system is non-LTI, may or may not be LTI, may be LTI. D option, none of these. Tell me guys, which option is correct? Which option is correct? Tell me everyone. Based on the convolution property, yes, based on the convolution property, what you can say, Monica, what you can say, based on the convolution property, you can say that the resultant will also be LTI. Okay, answer is Agra. If you are combining two LTI system, then according to convolution, you can say that the YT will be, let's say this is H1T and this is H2T. So the resultant will be H1T convolution H2T. I'll tell you about the convolution also. H1T convolution H2T. You'll get this function. Since you are doing the convolution, the resultant function will also be LTI. Okay, so remember this point. Okay, Ankit Joshi sir will join at 12:05. So I have 10 minutes. So let's continue with the next question. So this is question 1. Those students who don't know this, I'll repeat this in the next session. Now question number 2. Now tell me, series interconnection of two non-linear system. Tell me guys, let's say you have one non-linear system, and there is one more non-linear system. Can it be linear? Tell me guys, the resultant system may be linear, may not be linear. Tell me which option is correct. A option, resultant system is linear always. B option, non-linear always. May be linear, may not be linear. May be linear, it may be linear. D option, none of these. Tell me guys, which option is correct? Tell me everyone, which option is correct? There is a series connection of two non-linear systems. If there is a series interconnection of two non-linear systems, which option is correct? Will it be non-linear? Will it be linear always, or maybe linear? Tell me which option is correct. Tell me everyone, which option is correct? Do it fast. Yes, the answer is Calcutta. Let me give you an example. Let's say this system is yt equal to xt plus 1. One system is this, and the other system is xt minus 1. Yt equal to xt minus 1. Or you can take one more example now. Let's say this is yt equal to x square t. and this is yt equal to root xt. Now if you combine them, let's say the input is some x1t, so here the output will become x1 square t, and if you take the root of this system, you will get x1t again. So you can say that the final result yt is equal to x1t. The final result yt will become equal to x1t. Is it fine? And this is a linear relation. Individual system are non-linear. This is non-linear because it is making square of the input and it is taking root of the input. So again it is non-linear, but the resultant may be linear. Resultant may be linear. Okay. So answer is Calcutta. Is it fine? I hope it is clear. I have given you the example. There is one more example like this. Let's say for one system, whatever input is, output is 1 plus xt. Okay. And the next system, whatever input is, you just subtract 1 to it. Then this 1 will be removed. Okay, because let's say you put xt here. So for this system, the output is xt plus 1. This will be the output of first system. Now, whatever the input to the next system, you subtract 1 to it. Okay, if you subtract 1 to it, you will get xt again. So the resultant output is xt again, yt equal to xt. So again, it's a linear, it will become a linear system, but the individual system are non-linear. So you can say that if the individual system are non-linear, then the resultant may be linear. Okay. Let's take one more example. Number 3. Let's say we have one linear system and one non-linear system. One non-linear system, and they are connected in cascade. Now tell me the resultant. The resultant will be linear. Tell me guys, resultant will be linear, non-linear always, maybe linear, okay, maybe linear, and D option, none of these. Tell me guys, none of these. Tell me everyone, which option is correct? One is linear, one is non-linear. Tell me which option is correct. It may be linear always, it will be linear always, non-linear always, may be linear, none of these. Tell me guys, which option is correct? Tell me everyone, which option is correct? Which option is correct? Yes, answer is Bombay. Okay, answer is Bombay. Whenever we have linear and non-linear system, if one non-linear is there, if only one non-linear is there, you can't make it linear. Okay, you can't make the overall system as linear. To make the overall system linear, what you need to do is you must have at least two non-linear, at least two. If there is only one non-linear, you can't make it. Okay, at least two non-linears should be there so that you can reciprocate what the first system has done. You can reciprocate that with the next system. So there must be at least two non-linear system to make it linear. But if there is only one non-linear, you can't make it linear. Okay. So in this case, you have only one linear. That's why you can't make it. Let's come to the next question. Question number 4. Okay. Let's come to the question number 4. So in question number 4, series interconnection of two time variant may be variant. So this is time invariant system. Let me interconnection of two time variant. Okay, this is time variant. This is time variant, and this is also time variant. Now tell me the overall. Overall maybe will be time invariant always. Will be time invariant always. Okay. B option, time variant always. C option, maybe time invariant. D option, none of these. None of these. Tell me guys, which option is correct? Do it fast. Which option is correct? Which option is correct? Do it fast. Let's see how many of you can solve it. Do it fast. Which option is correct? Time variant, time variant. There are two time variant system. Okay, there are two time variant system, and we are making in cascade form. Now tell me which option is correct. Will it be time invariant always or time variant always? Maybe time invariant, none of these. Tell me guys. Tell me which option is correct. Do it fast. Raghuram is so confident that he is typing B 6 times. Okay. time variant always. Okay, tell me guys, anyone else? Okay, so the students are saying B, but the answer is C. Okay, answer is Calcutta. How? Let's take an example. Let me give you an example. Let's say the first system is yt equal to xt by 2. This is time variant. It is scaling the input by half. Now let's take this as yt equal to x of 2t. Now again it is time variant. But now what this system is doing? This system is reciprocating that thing. It has scaled by half, it has scaled by 2. So the overall output will be xt again. Whatever input you are doing, you'll get the same output, yt equal to xt, and this relation is time invariant. Okay, so you can see that whenever you have time variant system, you have to reciprocate that. Okay, so you can connect one more system which can reciprocate that thing. So it may be possible, it may be possible that we get some system which can reciprocate the same operation that we have done in the previous system. Okay, so now it has scaled with half. So this system will scale with 2 so that it can reciprocate, and then you will get the time invariant system. Again, if you make time variant to be time invariant, there must be at least 2 systems, because you have to reciprocate the thing. So at least 2 systems should be there. Otherwise you can't make the cascade of 2 time variant system as time invariant. Okay, at least 2 time variant systems should be there. Is it fine, guys? Have you understood? Say yes or no. Answer should be Calcutta. It may be time invariant. Okay, it may be time invariant. Let's come to the next thing. Let's come to number 5. Let's say there is one unstable system and again unstable system. I have cascaded 2 unstable systems. Now tell me the overall system. A option, overall system will be stable always. Stable always. B option, unstable always. Unstable always. Tell me guys, maybe stable, and D option, none of these. Tell me guys, which option is correct? None of these. Tell me guys, tell me which option is correct. Let's say you have one unstable system and there is one more unstable system. You have 2 unstable systems. Now tell me, will it be stable? Can it be stable? Tell me guys, can it be stable? Stable always, unstable always, maybe stable. Tell me which option is correct. Tell me guys, which option is stable? Which option is stable? Okay, I think it may be stable. Okay, let's take an example. Let's say for this system, the transfer function is T1s is s minus 2 divided by s minus 3 into s plus 4. Tell me guys, is it stable or unstable? Tell me. Look at the pole. Look at the pole of this system. The pole of this system are in right half. One pole is right half. If one pole is in right half, then you can say that this is unstable. Fine. Now let's take 2 other system, T2s. T2s came out to be s minus 3 divided by s minus 2 into s plus 5. Now tell me about this system. Is it stable or unstable? Tell me guys. Is it stable or unstable? Tell me. Is it stable or unstable? Again it is unstable because one pole is in the right half. Now if you cascade them, if you cascade them like this, then obviously their transfer function will get multiplied. If their transfer function will get multiplied, then it will be like this. It will be like this. S minus 3 divided by s minus 2 into s plus 5. So you can see that this will cancel this will cancel this. Now you can see the pole. The pole will be in the left half of the S-plane. Tell me guys, is it clear or not? So answer will be maybe stable. So the overall system may be stable. Ankit Joshi sir is saying hello. Okay, let me ask him whether he is ready. It may be stable guys. It may be stable. Answer is may be stable. It may be stable, it may not be stable. So may be stable is the correct answer. Okay. because it may not be stable. No? It might be possible that the overall system may be unstable. So that's why the C option is correct. Calcutta is correct. Is it clear, guys? Okay, I think Ankit Joshi sir is ready. Let me call him. But before that, I want you to solve one more question. Okay, let me give you one more question. Let's say I have question number 6. Let's say I have one stable and one unstable. Tell me, one unstable. Tell me the resultant system. What can be the resultant system? It will be stable always. It will be unstable always. Unstable. It may be stable. May be stable. Tell me, guys. And D, none of these. None of these. Tell me, everyone, which option is correct? Tell me. Okay, let me talk to Joshi sir so that he can join and then he can continue. So guys, the answer of this question is C, Calcutta. Okay, you can take an example like this: s minus 2 divided by s plus 3 and s plus 4. Okay, this is a stable system, and there is one more system: s minus 2 into s plus 1 into s plus let's say s plus 6. Now if you cascade them, now you can see that this s minus 2 will cancel. So the overall system will become stable. So overall system may be stable. Is it clear, guys? I hope it is clear to everyone. Okay, I hope it is clear to everyone. So now from this point onward, Ankit Joshi sir will continue. So I will teach you all these type of system and invertible, non-invertible and LTI system. I'll teach you everything in the next session. Next session will be tomorrow, or maybe you will be get notified. So in the next session, I'll discuss about LTI system. Now I'm stopping it. So you'll see a glitch of 10 seconds, and then Ankit Joshi sir will continue from this point onward. So thank you guys, and don't forget to like this session and subscribe our channel. Okay, so please subscribe this channel and like this session. So I'm giving this class to Ankit Joshi sir, and from this point onward, Ankit Joshi sir will continue. So
good morning, students. Am I audible to all of you? Good morning, students. Hello, everyone. Students, this is Ankit Joshi, and I welcome you all on India's largest e-learning platform, BYJU'S Exam Preps YouTube channel. So, students, as Ashu sir has already started signals and system for you, I will be just adding to his class. And in this session, we will be discussing about Fourier transform, applications of Fourier transform, and then we'll move towards the Z transform. So welcome to this session. I request all of you to hit the like button if you have not done so. Request number two is share the link in all your contacts. I request all of you to share the link in all your contacts so that every needy student will get the best concepts from Fourier transform and its application. Students, I request all of you to hit the like button, share the link in all your contacts. This is my urge before you, and everyone should stay tuned for the next 2.5 hours to get the best of the concepts, best of the questions, and best applications from Fourier transform. Students, some of the students have already shared, and those who have not liked this session, I request all of you to hit the like button and stay tuned for the next 2.5 hours, and I will be providing you the best content of Signus and Systems application based chapters, that is Fourier transform. So students, let's start. So this is the brief introduction about me. Students, I have been teaching in this domain, gate ESC domain, since past 19 years, and yes, you can say 16 plus years, and my subjects of interest are engineering mathematics, signals and system, and analog circuits. Okay, so we are here in the marathon session for signals and system. All of you, welcome to the session. Students, marathon session for GATE 2023 is already started. You can see the entire BYJU'S exam prep, EC electrical instrumentation, computer science team on your screen. So let's move to the next frame. One very crucial information for the GATE 2024 aspirants. This is another request to you. Students, share to your juniors that your favorite Abhinav Negi sir will be coming live on 15th of January at 12:30 noon on our BYJU'S exam prep. Yes, this is our app. So on our app, you can find a big mantra session from Abhinav Negi sir, aspirants for GATE 2024. 90% scholarship. Yes, students, we are also providing scholarships to the student who are performing very nice. So that is scheduled on 8th of January, 12 p.m. Student, while studying signals and system, one thought comes to our mind that there are two types of analysis: time domain analysis and frequency domain analysis. So when you are looking for frequency domain analysis, we have got four major tools: Fourier series, Fourier transform, both in discrete domain and continuous domain. So you have continuous time Fourier series, discrete time Fourier series, continuous time Fourier transform, and discrete time Fourier transform. So ultimately, four types of mathematical tools. Two more additional tools like Laplace transform and Z transform. So entirely we can say that to do the frequency analysis, we require all these mathematical concepts. So student, let me give you an idea about which mathematical tool is being utilized under which circumstances. So upcoming 2 hours and 30 minutes will be, yes Navneet, everything will be covered beta. So students, what you can see on the screen, see here, if I am having a continuous time signal, let us say the name of the signal is x of t. If this signal is continuous time and aperiodic, then we will be using continuous time Fourier transform to see its spectrum, that is frequency domain counterpart. So after taking continuous time Fourier transform, you will get x of omega. Are you following? This is first class of signal. If you are having x of t, which is no doubt continuous time, but this time it is periodic. अगर हमारे पास continuous time and periodic signal है, in that case you have to go for Fourier series. Of course, continuous time Fourier series. So continuous time Fourier series we generally denote by exponential Fourier series, that is Cn. Okay. So this is the basic type. If you are having continuous time signals, if it is aperiodic, go for Fourier transform. If it is periodic, go for Fourier series. Third class signals, that is discrete time signals. Generally we denote discrete time signals by x of n. So all my dear students, if this x of n is discrete time plus aperiodic, then we use discrete domain, that is discrete time Fourier transform, and discrete time Fourier transform is denoted by x of e raised to j omega. Okay. On the other hand, if this x of n is discrete time and periodic, discrete time and periodic, then you should go for, yes Rajesh, so then you will go for discrete time Fourier series. So discrete time Fourier series I generally denote by CK in my classes. Okay, so we have got 4 different types of mathematical tools for 4 different classes of signals. Okay, so just go through this frame, students. I'll just hide myself for some moment so that you will be able to see the entire frame in one go. So students, as you can see on the screen, that if you are having continuous time and aperiodic signal, which mathematical tool you are using? Continuous time Fourier transform. If you are having continuous time and periodic signal, then you should go for Fourier series, continuous time Fourier series. Discrete time aperiodic signal hai to discrete time Fourier transform is the mathematical tool. For discrete time periodic signal, discrete time Fourier series. So students, this particular table is very useful for you in answering some questions related to which type of transform, which type of mathematical tool is used to find a different type of response. Chali. Moving to the next. Comfortable with this? Next frame. Next frame is giving us the idea about what are the natures. What are the natures of these transforms? Please concentrate. See here. When we talk about a signal x of t, which is continuous time and aperiodic, we are taking continuous time Fourier transform and we get x of omega. Now the question comes to our mind that what is the nature of this spectrum? Is spectrum का nature क्या होगा? See here, continuous in time domain changes to aperiodic in frequency domain, and aperiodic in time domain changes to continuous in other domain. So if someone asks you what is the nature of x of omega, what is the nature of this x of omega spectrum? Continuous in frequency and aperiodic. Number two, x of t, which is continuous time and periodic. Students, are you following? So just now we have seen the mathematical tool for periodic signal is Fourier series. So continuous time Fourier series will be the mathematical tool. And what will be the nature of the Fourier series? The nature of this Fourier series, Hanji, continuous changes to aperiodic and periodic changes to discrete. Wow. Discrete in frequency. Discrete in frequency. So student, if the signal is continuous time and periodic, then Cn, that is its Fourier series, will be discrete in frequency and aperiodic. Number 3, x of n. Arey bhai, x of n denotes the discrete time signal. So it is discrete time and let us say it is aperiodic. So student, always remember that for discrete time aperiodic signal, we should go for discrete time Fourier transform. And discrete time Fourier transform is denoted by x of e raised to j omega. Now, what is the nature of x of e raised to j omega? Please concentrate. This discrete changes to periodic. Discrete changes to periodic and aperiodic changes to continuous. Yes? Raghuram, what happened beta? Cn is the Fourier series, continuous time Fourier series. Cn, it is aperiodic. See, continuous changes to aperiodic and periodic changes to discrete. Beta Cn, this Fourier series is not continuous. Fourier series is discrete spectrum. Discrete in frequency and aperiodic. X of n. If this x of n is discrete time, discrete time, and what we say, periodic. If you are having a periodic signal in time domain, then you should be using Fourier series, discrete time Fourier series. So students, discrete time Fourier series is denoted by CK. Discrete changes to periodic and periodic changes to discrete. So this is how this table is being formed. So if the students are being confused in this approach, I will be giving you a thumb rule for this. Please concentrate here. In any domain, if your signal is continuous, okay, so when the domain changes, this continuous changes to aperiodic. Yaad rakhna. And aperiodic changes to continuous. Aperiodic changes to continuous. Very simple. Yes, sir. Number 2, if your signal is discrete in any domain, then it will become periodic when domain changes. It will become periodic when domain changes. And if any signal is periodic in any domain, then when domain changes, it changes to discrete. Understood? This logic is being applied in writing down these conclusions. Okay? Yes, sir. So actually this is called as Hermitian table. This is called as, not Hermitian table, duality table. Duality table. Duality table. See here, this is the duality table. Continuous changes to aperiodic changes to continuous, discrete changes to periodic changes to discrete. I'll just hide myself so that you can have a look over this. Comfortable, everyone? Next. Next comes the Hermitian table. See here. In time domain, we have one nature, and in frequency domain we have another nature. See here, in time domain, if our signal is real and even, in time domain if our signal is real and odd, in time domain if our signal is imaginary and even, in time domain if our signal is imaginary and odd, what are the possibilities, what are the counterparts in frequency domain, what will be the nature of their spectrums in frequency domain? See, in time domain our signal is real and even, so just see this, whenever you have even signal in time domain, the same nature will be copied to frequency domain. So real and even will be copied. See here, in time domain my signal is even, same nature will be copied to frequency domain. When in time domain my signal is odd, odd will remain odd, but adjacent nature will change. Real changes to imaginary, imaginary changes to real. So odd will remain odd, odd will remain odd. But what is the adjacent nature? Adjacent nature is real. Real changes to imaginary. What is this adjacent nature? कौन सा nature है ये? Imaginary. This will be changed to real. So this is called as Hermitian table. So whatever we have discussed till now, many times we have questions based on this concept as well. Okay, so just have a look over this. Real and even, copy कर दिया. Same nature. Imaginary and even, copied to frequency domain. Same nature, imaginary and even. Okay, and when there is odd in one domain, odd will remain odd, but real changes to imaginary. Odd will remain odd, but imaginary changes to real. This mapping is called as table. Okay, this will also help you in snatching some marks based on this type of questions. Comfortable, everyone? I need response from every one of you. जितने भी बच्चे online हैं, everyone should respond. So these are the very basics of the frequency spectrum, frequency response. Thanks a lot for your beautiful response, students. So students, an announcement for you. General aptitude marathon session is coming soon. 15 marks in just 15 hours. Don't miss out. Your favorite Rakesh Talreja sir will be taking up this class for aptitude. One more big announcement. Nothing is impossible. Rakesh sir, along with me, non-stop maths marathon complete syllabus in 2 days. Yes, coming soon. So just stay tuned yourself for these big sessions. So students, now we are starting the Fourier transform. Till now we were discussing about some basics. Now we are actually starting this Fourier transform. Give me 1 second. Sorry. In upcoming weekends, beta. All set? Students, please concentrate, huh? As I said that if x of t is a continuous time and aperiodic signal, and we are all interested in observing its frequency response. So since it is aperiodic, you should go for Fourier transform. And since it is continuous time, you should be taking continuous time Fourier transform. So continuous time Fourier transform. After taking continuous time Fourier transform, we will get x of omega. What is the nature of x of omega? Please concentrate. As per the duality table, aperiodic changes to continuous. So our spectrum will be continuous in frequency domain. All set? All understood? And as per the duality table, continuous changes to aperiodic. So student, if your signal is continuous time and aperiodic in time domain, then when you take its continuous time Fourier transform, you will get its spectrum x of omega, and the nature of x of omega will be continuous in frequency and aperiodic. Comfortable with this? Now, we are interested in writing a mathematical expression for determining this x of omega. That is called as definition of Fourier transform. Definition of Fourier transform. Which Fourier transform, bachcha log? Continuous time Fourier transform. So whose Fourier transform you want to find? I want to find Fourier transform of x of t. So I will be writing an integration whose limits are from minus infinity to plus infinity, and I will be writing a blank space here and e raised to minus j omega t dt. Okay, and in this blank space we supposed to write that function whose Fourier transform needs to be determined. So students, we want to find the Fourier transform of x of t. So I will be just replacing x of t here, and the right hand side will be a function of frequency omega, x of omega. Okay, so this is the definition of Fourier transform. For your understanding, x of t is our time domain signal. X of t is time domain signal. What about x of omega? X of omega will be its frequency response of x of t, or you can say that Fourier transform of x of t. Comfortable? What is this capital F? Capital F denotes the Fourier transform operation. It is called as Fourier transform operator. Comfortable, everyone? Yes, sir. Now, this is the expression for inverse Fourier transform. Students, when you take Fourier transform of x of t, you are getting x of omega. At the same time, when you take inverse Fourier transform of x of omega, you will get x of t. So we can say that x of t and x of omega forms a Fourier transform pair. So inverse Fourier transform of x of omega will be x of t. Inverse Fourier transform of this function will be x of t, and we can achieve this mathematically. इसको हम mathematically achieve कर सकते हैं. कैसे? 1 by 2 pi integration from minus infinity to infinity. Be careful. Here we have e raised to j omega t d omega. This integration is with respect to omega, and this integration was with respect to t. Take care. And here in this blank space, you're supposed to put that function. IFT needs to be determined. Okay, so Fourier inverse is nothing but inverse Fourier transform operator. What are these Dirichlets condition? Dirichlets conditions are the necessary condition for a signal to have a valid Fourier transform. किसी भी सिग्नल का Fourier transform exist करेगा या नहीं करेगा depends whether the signal is satisfying Dirichlets condition or not. Is that clear? The first condition is x of t must be absolutely integrable. Absolutely integrable means modulus of x of t when integrated must give you a finite value. Must give you a finite value. Number 2. X of t must have, see here, if x of t is having discontinuities, if x of t has discontinuities, then number of discontinuities should be finite. And amplitude of discontinuity should also be finite. These are some basic points. You may get this, you may not get this. Okay, but at this point of time, you should not worry about many of the things. Okay, you should also worry about how to solve problem. You should worry about problem solving aptitude and attitude. The students, if these conditions are satisfied, that x of t is absolutely integrable, then Fourier transform will exist. Number 2, if x of t has discontinuities, then in that case number of discontinuities should be finite and amplitude of each of the discontinuity should also be finite. Okay, so if any of these conditions are satisfied, either one or two or both, then Fourier transform will exist. Listen carefully. Either of these conditions are satisfied, then Fourier transform will exist. Either of these or both of these are satisfied, then Fourier transform will exist. If the first condition is satisfied, Fourier transform will exist. First not satisfied, second satisfied, then also Fourier transform will exist. Both are satisfied, then also Fourier transform will exist. Okay? Yes, sir. Now please concentrate here. देखो बच्चों, I want to generate a relationship between Laplace and Fourier. Please concentrate. Laplace transform of x of t denoted by x of s. It is minus infinity to infinity e raised to minus st x of t dt. This is Laplace transform's definition. Continuous time Fourier transform's definition. X of omega. Fourier transform of x of t minus infinity to infinity. No, x of t e raised to minus j omega t dt. Now listen carefully. You can just realize that sorry, in Laplace transform, when you put s equal to j omega, you are getting Fourier transform. So Laplace transform evaluated for s equal to j omega gives you Fourier transform. And here I have written this star, terms and conditions applied. You can determine Fourier transform from the result of Laplace transform only for those signals which are absolutely integrable. If the signal is not absolutely integrable, then this relation will not hold good. Go through this. Fourier transform of a signal x of t can be obtained from the result of its Laplace transform only if x of t is absolutely integrable. If x of t is not absolutely integrable, then its Fourier transform cannot be derived from the result of Laplace transform. देखो बच्चों, if you go for Laplace transform of e raised to minus at u of t, this is exponential decay, so this is absolutely integrable. So when you take its Laplace transform, you are getting 1 upon s plus a. In this result, when you put s equal to j omega, you will get Fourier transform. This is Fourier transform of e raised to minus at u of t, correct? Since this signal is absolutely integrable, its Fourier transform can be obtained from the result of Laplace transform. Okay, Anji. Consider this u of t. This is not absolutely integrable. So its Laplace transform exists, that is 1 by s. But when you put s equal to j omega, you will get 1 upon j omega, which is not equal to Fourier transform of t. Okay, so simple logic. If you have an absolutely integrable signal, then its Fourier transform can be obtained from the result of Laplace transform by putting s equal to j omega. If signal is not absolutely integrable, then its Fourier transform cannot be obtained from the result of Laplace transform. How many of you understood this concept? Now see here. Fourier spectra. What is this Fourier spectra? When you have some signal x of t and you take its Fourier transform, you are getting x of omega. X of omega is a complex function which can be split into two parts: x of omega magnitude and its phase angle. When you plot x of omega magnitude versus frequency, you will get magnitude spectrum or amplitude spectrum, or you say amplitude response. When you plot theta omega against frequency, you will get phase spectrum, or you say phase response. Comfortable, students? Yes, go through this. This is magnitude spectrum and this one is phase spectrum. After the basics of Fourier transform, we are just entering into the properties. So linearity property, it's the most simplest. I should not read out this one. Time shifting property. See here, x of t is having Fourier transform x of omega. So in time domain, if you are delaying a signal, shifting a signal, then its Fourier transform x of omega will get multiplied by complex exponential term. That's it. Raghuram, that fine? Chaliye. So x of t minus a, its Fourier transform will be x of omega multiplied by e raised to minus ja omega. Next. What happened? What is the theme in this? See here. Whenever a signal is shifted in time domain, its magnitude spectrum will not change, but only phase spectrum will change. See here. If this is your y of t and this is y of omega, see here, y of omega is e raised to minus ja omega and x of omega can be written as e raised to j theta omega into magnitude of x of omega. So we can say that magnitude spectrum no change, and phase spectrum changes. What kind of change? In the original phase of x of omega, minus a omega term is added. Frequency shifting property. If your signal x of t gets multiplied by some complex exponential term in time domain, then in x of omega, omega will be shifted by omega naught. If it is e raised to minus j omega naught t, then x of omega plus omega naught. So this is frequency shifting property. So whenever we are multiplying by some complex exponential term in time domain, in frequency domain we will see a corresponding shift. So this is frequency shifting property or complex modulation property. This is also called as complex modulation property. Time scaling property, the most vital one, important one. See here. Your signal x of t is having Fourier transform x of omega. And this x of t is time scaled by factor of a. Then what happens? It is 1 upon modulus of a x of omega by a. Now please concentrate here. If this scaling factor a is less than 1, it means expansion in time domain. and expansion in time domain corresponds to a is less than 1, so expansion in time domain. So here the scaling factor in frequency domain is 1 by a. So 1 by a will be greater than 1, so it will corresponds to compression in frequency domain. Understood? So expansion in time domain corresponds to compression in frequency domain and vice versa. This is a very important property. Compression in time domain corresponds to expansion in frequency domain. Expansion in time domain corresponds to compression in frequency domain. And both of these are accompanied by this operation, multiplication by 1 by a. Comfortable? Next. In the time scaling property, if the scaling factor is selected as -1, then you will get time reversal property. That is, if you are folding a signal in time domain, then it corresponds to folding a signal in frequency domain as well. Folding a signal in time domain corresponds to folding a signal in frequency domain. Now the most important one is the duality property. All of you please concentrate. See here. If x of t is having Fourier transform, of course continuous time Fourier transform as x of omega. In this x of omega, if you replace omega by t, then you will get capital X of t. So now this is a time domain signal. So its Fourier transform will be 2 pi times, in this small x of t, just replace t by minus omega. This is duality property in omega domain, that is in terms of omega. Frequency can also be represented as linear frequency f. So if you write x of t's Fourier transform as x of f, then this x of f is replaced by t, then its Fourier transform will be simply x of minus f. This is duality property in f domain. Both are important. Moreover, the first one we are more utilizing in signals and system. The second notation we are utilizing in communication systems. Yes, Ikram, we will be sharing this PDF in my Telegram group, Electronics by Ankit Joshi. I request all of you join that channel as well. Time differentiation property. If you are differentiating x of t in time domain, then what is the change in frequency domain? In frequency domain, the previous Fourier transform x of omega will get multiplied by j omega. That's it. So differentiation in time domain corresponds to multiplication by j omega in frequency domain. Thank you, Raghuram. Now, this one is very important. See here, frequency differentiation property. If x of t is having Fourier transform x of omega, then if this x of t is multiplied by minus jt in time domain, then in frequency domain x of omega will be differentiated. Wow, great. So understood this one. If I divide by minus j both sides, so minus j will be removed from the left hand side, and 1 upon minus j is nothing but j. Comfortable everyone? So this is differentiation in frequency domain. Frequency domain में differentiation. So students, time integral property. This one is also important one. I will give you the physical significance also. If x of t is having Fourier transform x of omega, and if you want to integrate, so always remember in any of the transform, whenever you take the integration of a signal, just change the dummy variable. So t is change to some dummy variable, u, tau, whatever you want, d tau. And the limits of integration of this property will be always minus infinity to t. Then its Fourier transform will be x of omega divided by j omega. See here, when you have taken differentiation in time domain, जब आपने टाइम डोमेन में डिफरेंशिएशन लिया था, in that case x of omega got multiplied by j omega. When you have taken integration in time domain, this x of omega gets divided by j omega. Okay, but when you integrate something, there is always some constants of integration. Yes or no? Yes, sir. So those constants of integration are the residual part. So pi x of 0 delta omega. Okay. So whenever you have a practical integrator circuit, this represents the offset output voltages present at the output of integrator. And this is due to some DC components present in the circuit. So you are doing integration in time domain, and that's why this is called as time integral property. Time convolution property. Here, if x1 t is having Fourier transform x1 omega, x2 t is having Fourier transform x2 omega, then x1 t convolved with x2 t, x1 t convolution with x2 t, their Fourier transforms will get multiplied together. ये Fourier transform आपस में multiply हो जाएंगे. Is that very clear? Convolution in time domain corresponds to multiplication in frequency domain. Good. See this one. Sorry. x1 t is having Fourier transform x1 omega, x2 t is having Fourier transform x2 omega, and when you multiply these two signals in time domain, you will be observing the convolution in frequency domain. See, multiplication in time domain corresponds to convolution in frequency domain. Convolution in time domain corresponds to multiplication in frequency domain. Yes. So this property is time multiplication or frequency convolution property. But in this property, we are having this additional 1 by 2 pi. देखो बच्चों, area under x of t. We know that x of t is having Fourier transform x of omega. Definition of Fourier transform is x of omega equal to minus infinity to infinity x of t e raised to minus j omega t dt. Now this integration is with respect to t. You can select a particular value of omega. So I am selecting here omega equal to 0, both sides. So x of 0. So when you put omega equal to 0, you are getting the spectrum at omega equal to 0 on the left hand side, and on the right hand side you are getting this integration. E raised to 0 will become 1. So this is nothing but area under x of t. Integration of x of t is area under x of t. So area under x of t is value of the spectrum at omega equal to 0. Yes. Area under x of t, that is capital X of 0 minus infinity to infinity x of t dt. Is that clear? Let's move to the next property. Area under spectrum. Achha ji. Just think of the inverse Fourier transform formula. Fourier inverse of x of omega. क्या होगा ये? This will be x of t 1 by 2 pi minus infinity to infinity x of omega e raised to j omega t d omega. This is the format for inverse Fourier transform. Yes, Anirban, very nice. If you put t equal to 0, this integration is with respect to omega. You can select a particular value for t. So x of 0. You can cross multiply this 2 pi on the left hand side. So you will get minus infinity to infinity capital X of omega d omega, and this is nothing but area under x of omega. Area under x of omega means what? Area under the spectrum. We have done with 13 properties of Fourier transform. Now the 14th, last but not the least, that is Parseval's theorem. Here comes. X of t is the signal in time domain. After taking its Fourier transform, we are getting x of omega. Yes, sir. So energy of this signal x of t will be minus infinity to infinity x of t modulus square dt. This is how we calculate the energy in time domain. The same energy can be calculated with the help of this spectrum also. It is 1 by 2 pi minus infinity to infinity. Yes, this integration utilizes x of omega. So x of omega, hello everyone, x of omega modulus square d omega. Now, here comes your first question. Yes, Anirban, it's Relics power theorem. Parseval's energy theorem and Relics power theorem. देखो बच्चों, please concentrate. Actually, I am not interested in the answer of this question. I am interested in the process flow. देखिए, starting with x of t. In this x of t, if you time scale by 1 by 3, you will get x of t by 3. Then, okay, this is our first step. This is second step. This is third step. Okay. Then plus 2 means advance by 2. Advance by 2 units. So you will get 3 in the denominator. T will be replaced by t plus 2. Comfortable? Then third step is this implementation of 5. That is time scale by a factor of 5. Everything will remain as it is. Just replace t by 5t. Now fourth one is this minus sign. In order to implement this minus sign, you need to time fold time fold, that is folding. So wherever you have t, that t will be replaced by minus t. So minus 5t plus 2 upon. So in this way, in these steps, we are getting the desired signal. Okay. At last, we can multiply by 3. No issues at all. So amplitude is scaling by a factor of 3. This will be giving you 3 times x of minus 5t plus 2 by 3. Comfortable, bachcha log? So these are the correct sequence of steps. These are the correct sequence of steps to generate this signal starting from x of t. Now we will be writing their corresponding Fourier transforms. So just now we have gone through many properties. We will apply them. So this double-sided arrow represents what? Fourier transform. And now it's our turn. Please concentrate. X of t's Fourier transform is x of omega. See, when you are doing time scaling by 1 by 3, okay, so time scaling by a factor of a, it is 1 upon a x of omega by a. 1 upon 1 by 3, x of omega upon 1 by 3, 3 omega. Now advancing by a factor of 2. When you are shifting the signal in time domain, in frequency domain, it will multiply it by complex exponential term e raised to j 2 omega. Due to this advancing operation e raised to j 2 omega, then what? 3 times x of 3 omega. Then time is scaling again by a factor of 5. So 1 upon 5 x of omega by 5. So 1 by 5, okay. And wherever you have omega, that omega will be replaced by omega by 5. Then folding. Folding in time domain corresponds to folding in frequency domain. Wherever you have omega, that omega will be replaced by minus omega. When t is replaced by minus t, omega will be replaced by minus omega. T by 5 e to the power j minus 2 omega upon 5 x of minus 3 omega by 5. Is that very clear? Now, at last, your amplitude is scaling by factor of 3. So in the previous result, simply multiply by 3. So 3 3s are 9. 9 by 5 e to the power. All of you understood this? All of you understood this approach? भाई रिस्पॉन्ड कीजिए. कोई भी लक्ष्य बड़ा नहीं, कोई भी लक्ष्य बड़ा नहीं, जीता वही जो डरा नहीं. Now students, you have got this answer, but in the options they have given you the representation in terms of f, not in terms of omega. This is in terms of omega. We want the representation in terms of f. So what we will do? See here. Do you know which function is this capital X? What is the nature of this capital X? No, we don't know. If you don't know the nature of the function, it is just an arbitrary function. So if there is an arbitrary function, then its argument, in the argument, omega will be replaced by f. Omega will be replaced by f. And outside the argument, omega will be replaced by 2 pi f. Understood? Yes, sir. Outside the argument, omega will be replaced by 2 pi f. 2 pi f into 2, 4 pi f by 5. And inside the argument, it is simply replaced by f. This is the representation in terms of. See here. X of t time scaled by 1 by 3 give you x of t by 3. Advanced by 2 will give you x of t plus 2 by 3. Again time scaling by 5, t will be replaced by 5t. So it is x of 5t plus 2 by 3. Time folding, t will be replaced by minus t. And when you amplitude scale by factor of 3, the previous result gets multiplied by 3. Now the corresponding Fourier transforms on the right hand side. Fourier transform of x of t is x of omega. Fourier transform of time scaling, your time scaling by factor of a is, it becomes x of at. Its Fourier transform will become 1 upon a, x of omega by a. So 1 upon 1 by 3, 3 x of omega upon 1 by 3, x of 3 omega. Advancing by 2, just you need to multiply by complex exponential term e raised to j2 omega. Remaining terms as it is. Again time scaling by factor of 5. So 1 upon 5 x of omega by 5. 1 by 5, and wherever you have omega, jahan par bhi omega hoga, omega will be replaced by omega by 5. Omega by 5, omega by 5. Then 3 by 5 e raised to minus j. Okay, folding in time domain, folding in frequency domain also. Okay. Then we reached up to this point. No, Karthik, not at all. So I have given you a logic that in the arbitrary function replace omega by f, and outside this replace omega by 2 pi. That's it. Comfortable? So this one is a very important question, very important variety in your upcoming exam. This involves the very basics of signals and system along with the properties of Fourier transform. Yes, move to this question. G of t, Fourier transform is g of omega. They have given you the graph. They have given you the graph for g of t. Okay, now students, just apply some basics. What you would have done to this g of t to obtain y of t, please see here. G of t advanced by 2 units. See, g of t advanced by 2 units, that is left shifted. So if it is left shifted by 2 units, this graph will appear between minus 2 to plus 2, means this interval. Okay, but the amplitude is not 2, amplitude is 3. So you want amplitude 3, so you just multiply it by 2 by 3. Amplitude scaling by a factor of 3 by 2. If you do amplitude scaling by a factor of 3 by 2, 2 gets multiplied by 3 by 2, 2 to cancel, you will get 3. So you will get 3 by 2 g of t plus 2. So this is nothing but our y of t. So what is y of t? Y of t is 3 by 2 g of t plus 2. Yes sir, very nice. So students, first step, what is the Fourier transform of g of t? Sir, g of omega. Then what is the Fourier transform of g of t plus 2? बताओ बच्चों, बताओ. G of t plus 2. It is e raised to j2 omega g of omega. Now, when you are amplitude scaling by factor of 3 by 2, just you need to multiply by 3 by 2 both sides. That's it. So you have got the Fourier transform y of omega. But you want f. You want the answer in terms of f. So 3 by 2 remains as it is. Yes, in the argument of the arbitrary function, just replace omega by f, and outside this replace omega by 2 pi f, e raised to j 2 into 2 pi f will be 4 pi f. Now you tell me. Yes, Karthik, understood beta? Karthik, Rohit, Ravi, Navneet, Raghuram, Payash. Next. Now, few important results which we are utilizing in the upcoming questions. Okay. So students, as you all know that the Fourier transform of delta t is 1. How we have obtained this one? See here. Fourier transform of x of t. Yes, minus infinity to infinity x of t e raised to minus j omega t dt. Now in this x of t, in the place of x of t, if you replace delta t, so when delta t gets multiplied by this, just you need to see what is the position of delta t. Sir, t equal to 0. So the adjacent function should be evaluated at 0. That is the answer. So e raised to minus j omega t evaluated at the position of impulse. That's it. E raised to 0, that will be 1. So Fourier transform of delta t is 1. So inverse Fourier transform of 1 will be delta t. Comfortable? See this one. Ashok, you should not ignore mock test as well as the test series. At least appear for some 8 tests. Chalo. E raised to j omega t. This is complex exponential term. See. Fourier transform of delta t is 1. By duality property, this 1 is brought to the time domain. So its Fourier transform will be 2 pi times delta of minus omega. But delta of minus omega will be delta omega. So all my dear students, Fourier transform of 1 is 2 pi delta omega. Now if this signal is multiplied by complex exponential term, either e raised to plus or e raised to minus, then you can go for frequency shifting property. So in the Fourier transform, omega will be shifted by omega naught. So 2 pi delta omega minus omega naught in the first case and 2 pi delta omega plus omega naught in the second case. So this is how we obtained the Fourier transform of these functions. Next, cos omega naught t. So cos omega naught t is split into two parts, e raised to j omega naught t plus e raised to minus j omega naught t upon 2. And then we have written the Fourier transform of the two complex exponential terms simplified to obtain this formula. Pi times delta omega plus omega naught plus delta omega minus omega naught. In case of sine omega naught t, you will get j pi and a minus sign here. J pi and a minus sign here. That's it. That will come in sampling process Ramsking definitely. See here. Now, Signum functions Fourier transform. Please concentrate. Everyone concentrate here. See here. Let us say our x of t is Signum t. Correct? It is 2 times u of t minus 1. Comfortable with this? Differentiate with respect to t. So derivative of x of t will be x dash t. Derivative of u of t will be delta t. And derivative of minus 1 will be 0. Now take the Fourier transform. Fourier transform of delta t will be 1. Fourier transform of x dash t will be j omega times x of omega equal to 2. So what is this x of omega? X of omega will be 2 upon j omega. And what is this x of omega? It is Fourier transform of x of t, which is actually your signum t. So signum t's Fourier transform will be 2 by j omega. Comfortable with this? Yes, students. How we obtain signum functions Fourier transform? Not by classical approach, but by property based approach. Signum t is 2 u of t minus 1. So u of t will be 1 plus signum t upon 2. Taking Fourier transform both sides and apply the linearity property. You can separate ना, इसको अलग अलग कर लेते हैं. So 1 by 2 is out. Fourier transform of 1 plus Fourier transform of signum t. So Fourier transform of 1, how much? 2 pi delta omega. And Fourier transform of signum t, it is 2 by j omega. So divide by 2, you will get pi delta omega plus 1 by j omega. Very good, sir. So this is the Fourier transform of u of t. Pi delta omega plus 1 upon j omega. Comfortable? Yes, sir. Pi delta omega plus 1 upon j omega. And when you replace t by minus t, when you fold this u of t, you will get pi delta omega minus 1 by j omega. Pi delta omega minus 1 by j omega. Comfortable? Now, upcoming properties are the modulation property and Fourier transforms of Signum function. Okay, so Fourier transforms of sinc and rect function. So stay tuned. Just give me 1 minute. I'll be right back. See you, students. देखो बच्चों, x of t's Fourier transform is x of omega. If this x of t is multiplied by cos omega naught t. Then its Fourier transform can be obtained by two methods. One is by frequency shifting property, another by frequency convolution property. And remember the result, what you are getting. See, this x of omega naught will be dislocated at two positions. One at omega naught, another at minus omega naught. So two replicas will be formed, and each of the replicas amplitude will be half of the amplitude of the original replica. This is the logic. Okay, it means if this is your x of omega, okay, so Fourier transform of this function will be one replica will be available at omega naught, another replica will be available at minus omega naught, same width replicas, but height will be 1 by 2. So if this height is 5, it will be 5 by 2. Are you following? So this is modulation property. So they have given you this spectrum x of omega. We want the spectrum of 10x of t, 5 pi t. Okay, great. So y of omega will be 10 as it is. Yes, see here. X of t's spectrum is x of omega. Great. So what you can do here, you will be getting two replicas. X of omega plus 5 pi and x of omega minus 5 pi. And each of these replicas are multiplied by 1 by 2. So you will get 5 times x of omega plus 5 pi plus x of omega minus 5 pi. Comfortable? If you wish to sketch the spectrum, so just draw two such blocks, one on the left side, one on the right side. Each one is centered about 5 pi and minus 5 pi. This one is minus 5 pi, this one is plus 5 pi. Now see, what is the width here? Width kahan se kahan tak hai? Width is 2 pi. So it is pi units on the right of 0. So pi units on the right of minus 5 pi is minus 4 pi. And pi units on the left side, it is minus 6 pi. Similarly, 6 pi is this point and this point is 4 pi. What about the amplitude? The actual amplitude is 2, which is halved. So it will become 1, but it is further multiplied by 10. So this will be 10. This height will be 10. Comfortable? This is the original spectrum. Comfortable बच्चा लोग? Fourier transform of Rect function. See, what is this Rect? Rect t. A rectangular pulse of total width 1. So width is 1, it means it is from minus 1 by 2 to plus 1 by 2 and height is 1. This is Rect function. So Rect function's Fourier transform, you can just find out by applying the definition. I am not giving you that derivation right now, but Rect function's Fourier transform is 2 by omega sine omega by 2. Comfortable? Yes, sir. So sine omega can be replaced by 2 pi f upon 2. This is 2 upon 2 pi f. So bachcha log, this 2 and 2 gets cancelled. So you are getting sine pi f. 2 gets cancelled. You are again getting pi f in the denominator. So sine pi x upon pi x is sinc x. Sine pi x upon pi x is sinc x. Okay. If it is sine pi f upon pi f, it is sinc f. If it would be sine pi t upon pi t, it would be sinc t. So this is nothing but sinc f. Comfortable? So you can say that Fourier transform of rect t is either 2 by omega sine omega by 2 or sinc f. Comfortable? See here, rect t Fourier transform is sinc f. Very nice. This sinc f can also be written as f is omega upon 2 pi na. So this can also be written as sinc omega by 2 pi. लिख सकते हैं भाई. Now see here. See here. Sinc t Fourier transform is rect f. By duality property, this rect f is brought to the time domain. It will become rect t. And sinc t is brought to the frequency domain. It will be sinc of minus f. But sinc of minus f is sinc f. So we can say that rect t Fourier transform is sinc f. Rect t Fourier transform is sinc f. That's what we have. Comfortable? And sinc t Fourier transform is rect f. Sinc t Fourier transform is rect f. Rect t Fourier transform is sinc f. Just now we have seen sinc t Fourier transform is rect f, and f can be written as omega by 2 pi. You know what is this? This 2 pi is the width, that is from minus pi to plus pi. Height is 1. This is your rect omega by 2 pi. This one is the most important relation. Here, if you have a function sine at upon pi t, sine at upon pi t, then its Fourier transform will be rect omega upon 2 times this a. This width is 2a minus a to plus a. Amplitude is 1. Okay. So this is how we determine the Fourier transform sine at upon pi t. Amplitude is 1 minus a2 plus a. Now please concentrate. See, impulse response and frequency response of low pass filter. Students, if you are having a low pass filter whose cutoff frequency is a, so this will be its spectrum. This will be the spectrum of low pass filter. So this is the spectrum of low pass filter. So this is the impulse response of low pass filter. So many of us are aware of the frequency response of low pass filter, but we are not aware of its time domain counterpart. Its time domain counterpart is simply sine at upon pi t. Comfortable? See here. Frequency response of a low pass filter. Here A is the cutoff frequency. It is rect omega by twice A. So its inverse Fourier transform will be the impulse response. So impulse response will be sine a t upon pi t. This is the impulse response. Respond कीजिए. See here. They have given you the impulse response of a low pass filter. We want the frequency response. So frequency response means its Fourier transform. It is rect omega upon twice a. Here a is 100 pi. So this will be rect omega by 200 pi. If you want to sketch the plot, width is 200 pi. It means it is from minus 100 pi to plus 100 pi. And this height is nothing but h of omega. This is 1. So this is the spectrum, and this is the plot of the spectrum, and this is simply its mathematical format. In this question, we need to find out the impulse response. So let us first formulate h of omega. What is h of omega? It is 5 times sine at upon pi t. 5 times rect function omega by twice a, like this. This is h of omega. So its inverse Fourier transform will be h of t. It is 5 times sine at upon pi t. This is the impulse response. If frequency response is given, we need to find the impulse response. So we need to take the inverse Fourier transform. So this is the entire summary of Fourier transform of Rect and sinc functions. Please go through it. One very important formula is missing here, that is sine at upon pi t. Fourier transform is Rect omega by twice a. All of you can take the screenshot of this. Done? This is the Fourier transform of Gaussian function. Now students, Gaussian function means normal distribution type function. So if you are having a Gaussian function like this, then its Fourier transform will be root of pi by e raised to minus omega square by 4. This is also Gaussian. So Gaussian function's Fourier transform is also Gaussian. I'm again showing you the previous slide. Done, Karthik? Fourier transform of periodic impulse train. Fourier transform of periodic impulse train. See, if you are having an impulse train delta t minus n ts, whatever you say, summation from n equal to minus infinity to infinity, then its Fourier transform will be omega s. One more impulse train from minus infinity to plus infinity, delta omega minus n omega s. What is this omega s? Omega s is 2 pi by ts. That's it. So Fourier transform of periodic impulse train is another impulse train, another period. Moving to the next. Now the applications of Fourier transform. Applications of Fourier transform. First one is the distortionless transmission system. Distortionless transmission system. So students, in a distortionless transmission system, two operations are allowed. If any signal x of t is passed through a system and it undergoes these two operations, amplitude scaling and time delay, and you are getting an output y of t. So what kind of output you will get? See, x of t has gone through a delay operation. delay by td. So it will be x of t minus td. Further, it is amplitude scaled by factor of k. So it will become k times x of t minus td. So this is nothing but the output of this system. If these two operations are done on the input, then this system is said to be distortionless, as these two operations are considered as distortion free. So y of t, which is the output of a distortionless transmission system, it allows two types of operation: amplitude scaling and delay operation, that is shifting operation. So y of t is k times x of t minus td. Y of t is k times x of t minus td. Actually, this is the input-output relationship of a distortionless transmission system. Comfortable very much? Everyone understood this? Now, if you take Fourier transform, you will get y of omega k times x of t minus td. Apply time shifting property. It is e raised to minus j omega td into x of omega. So student, this is the input-output relationship and this is the Fourier transform equation. Now, if you divide y of omega by x of omega, you will get k times e raised to minus j omega td. And for your kind information, this is nothing but h of omega, that is frequency response. So h of omega of a distortionless transmission system is k times e raised to minus j omega td. Comfortable? Yes, sir. You can split this into two parts: h of omega magnitude and phase. So we can clearly say that magnitude is nothing but constant k and phase angle is nothing but minus omega td. This is magnitude spectrum and this is phase spectrum. Magnitude spectrum and this is phase spectrum. Comfortable? So for a distortionless transmission system, magnitude spectrum should be a constant and phase spectrum should be linear. Theta omega is minus omega td, y equal to mx. A linear value. Comfortable बच्चा लोग? Here. You can see the graph as well. So magnitude spectrum is a constant value against frequency and phase spectrum is a linear graph. Y equal to mx. M is minus td. M means slope. See, if theta omega denotes the phase response of a system, if theta omega denotes the phase response of a system, okay, then there is one term called as TP, that is phase delay, which is minus theta omega upon omega. There is another term called as TG, which is called as group delay. It is minus d by d omega of theta omega. Comfortable? Now, if the phase response of a system is linear, if you have a linear phase system, in that case, theta omega is minus omega td. So find out TP. TP क्या होगा? Use this formula, minus theta omega, that is minus omega td upon omega. So you will get td. What is tg? Minus d by d omega, theta omega. Theta omega is again minus omega td minus minus plus omega td. So td is constant, derivative of omega will be 1. So student, for a distortionless transmission system, we have linear phase. That is theta omega is minus omega td, and in this case Tp and Tg will be same. So for a linear phase system, you will get Tp equal to Tg and vice versa. Comfortable with this? For a linear phase system, phase delay is equal to group delay. For a linear phase system, phase delay is equal to group delay. See this question. Consider a transmission system h of omega with magnitude and phase response as shown in the figure. X of t is 2 cos 10 pi t and sin 26 pi t is given to the system. What will be the output? So students, this signal has got two frequencies, omega 1 equal to 10 pi and omega 2 equal to 26 pi. Now see here. On the magnitude spectrum, where does this 10 pi lies? Here, this is omega 1, which is 10 pi. And 26 pi will be somewhere between 20 pi to 26 pi. That is omega 2. So for omega 1 frequency, the gain offered by the system is 2. For omega 2 frequency, the gain offered by the system is 1. Okay, so we can say that for these two frequencies, gain k1 is 2 and k2 is 1. Comfortable with this? Comfortable? Now, what is the phase delay offered by the system for these two frequencies? So both of these frequencies are lying in the interval 0 to 30 pi. Okay, so for both of these frequencies, 10 pi and 26 pi, 10 pi and 26 pi, phase angle will be determined from this linear characteristic. So just determine the characteristic of this linear. This line is passing through origin, so its intercept is 0. So how to write down the equation? It is y equal to mx. Y means theta omega. Since line is falling down, slope will be negative, and slope is y upon x. So here y coordinate, either you take these 2 points or these 2 points or first and third point. Okay, I am taking these 2 points. So y coordinate is pi by 2 and x coordinate is 30 pi. So pi by 2 upon 30 pi. And this minus sign incorporates that decreasing slope. So y equal to mx, x is nothing but omega. So students, theta omega will be minus pi cancelled 1 by 60. So this is minus omega by 60. So for omega 1 equal to 10 pi, what is phase angle theta 1? It is minus 10 pi upon 60. That is minus pi by 6. For omega 2 equal to 26 pi. What is the phase angle? What is the phase angle? Tell me. Minus omega 2, that is minus 26 pi upon 60. So it is minus 13 pi upon 30. Correct? Yes, sir. So students, we have obtained theta 1 and theta 2. We have obtained k1 and k2. So what is the output? Output y of t will be, see here, there are two frequency components, cos 10 pi t and sin 26 pi t. Like this. Now These theta 1 and theta 2 will be added to these angles. So theta 1 is minus pi by 6. Theta 2 is minus 13 pi by 30. Correct? Now, existing coefficient is 2 and this will be multiplied by k1. So 2 will be multiplied by 2, that will be 4. Here existing coefficient is 1. It is multiplied by k2. K2 is 1. So 1 into 1 will be 1. So this will be the output. Bacha log, this is the output. Four cos 10 pi t minus pi by 6 sine 26 pi t minus 13 pi by 30. Option C is the correct answer. Okay. Now, in addition to this, if someone asks you which types of distortion are present in the output, so it means they are asking you whether amplitude distortion is present or not, whether phase distortion is present or not. See, amplitude distortion will be present. Why? Because the two frequencies are amplified by different gain factors. 10 pi frequency is amplified by gain k1 and 26 pi frequency is amplified by gain k2. So when two different frequencies are amplified by two different gain factors, amplitude distortion will have to be there. So amplitude distortion will be there. What about phase distortion? The two frequencies, the phase angle for two frequencies omega 1 and omega 2 are obtained from the same line. When the phase angles are obtained from same characteristic, phase distortion is absent. So in this particular question, our signal x of t has gone through phase distortion but no amplitude. Our system has gone through amplitude distortion but no phase distortion. Amplitude distortion is present and phase distortion is absent. Can I have your response on this? Students, now see here. In this question, they are talking about an RC low pass filter. RC low pass filter. Okay. So this one is the inputs Laplace, and this one is the outputs Laplace. Laplace of resistance will remain R and Laplace of this capacitor will be 1 by SC. Okay. So output Y of S is total input into same impedance upon total impedance. So Y of S upon X of S. This is transfer function of low pass filter. This will be, after taking LCM, SC cancelled, 1 upon 1 plus SRC. Very good. This is transfer function. In terms of frequency, omega, 1 upon 1 plus J omega RC. Very good. Now what we want? H of F denotes the frequency response of, okay, F1 be the highest frequency. So F1 is the cutoff frequency, right? So now see here. H of F1 magnitude upon H of 0 magnitude should be greater than equal to 0.5, 0.95. H of 0 magnitude for filters is 1. This should be greater than equal to 0.95. Very good. So magnitude of this, if I square this, I will get this expression. H of 0 magnitude is 1. So I just kept the denominator as 1. Okay. Magnitude will have under root. On squaring this, that under root will be removed. So 1 plus 4 pi square R square C square F square. Very good. Now 1 upon 0.95 square greater than equal to 1 upon 1 plus, just a moment, first multiply किया ना, हाँ, 1 plus 4 pi square r square c square f square, f in fact f1. Now on solving this you will get a frequency value f1, and that f1 will be 52.2 hertz. I hope you can do the calculations. Okay, on solving this inequality you will get this frequency f1 is 52.2 hertz. No Raghuram, 52.2 आएगा बेटा. So 1 divided by 0.95 whole square, 1.108, 1.108 greater than equal to 1 plus 4 pi square r square c square. Okay, now this 1.108 divided by 4 pi square r square c square. What is this r and c? R is 1k, c is 1 microfarad, so 1k into 1 micro, 10 raised to minus 3, so r square c square. So when you square this you will get 10 raised to minus 6. Just a moment, 1.08 minus 1 divided by 4 pi square into 10 raised to minus 6. And its square root. Are you following? Yes. So my answer is correct. 52.3 आता है, whatever. So nearest option is 52.2. You will get this answer. Shall I show you all the options? Yes, sir. Now, there is one more question related to this. See here. They are asking for the group delay. So what is theta omega? Theta omega is 1 upon 1 plus j omega rc. Okay. So group delay is minus d by d omega theta omega. Great. तो डेरिवेटिव ऑफ दिस टर्म क्या आएगा भाई? डेरिवेटिव ऑफ दिस टर्म बताइए. 1 अपॉन, हाँ जी, टेल मी डेरिवेटिव. फेज चाहिए ना, फेज. दिस इज नॉट फेज, दिस इज h ऑफ ओमेगा, राइट? लेट अस कैलकुलेट. This is h of omega, so theta omega will be minus tan inverse omega rc upon 1, correct? So dg minus d by d omega theta omega. So this minus and minus plus 1 upon 1 plus omega square r square c square further multiplied by derivative of omega rc, which is rc. So students, what is the frequency they are saying? 100. So f2 is 100, omega will be 2 pi 100, that is 200 pi. Shall we solve this? you will get the answer as 0.717 in milliseconds. Done? Comfortable everyone? Now see, Signum function's Fourier transform is 2 by j omega. Now, Signum T's Fourier transform is 2 upon j omega. So by duality property, yes, Ravi, RC is 10 raised to minus 3. What I have written? RC is 10 raised to minus 3. Yes, sir. So 10 raised to minus 3 square, it is 10 raised to minus 6. Correct? You'll get that answer 0.717. Now coming on to this. Signum T Fourier transform is 2 by j omega. Apply the duality. So 2 by jt. So it is 2 pi times signum of minus omega. By duality property I obtained this. Divide by 2 both sides. So 1 upon jt by signum of minus omega. Divide by pi both sides. Multiply by j both sides. Signum of minus omega. This will be signum omega and minus will be coming up front. So Fourier transform of 1 by pi t is minus j signum omega. Fourier transform of 1 by pi t is minus j signum omega. Comfortable? Yes, sir. Students, if I say I am having a system whose impulse response is 1 by pi t. So h of t is 1 by pi t, that is the impulse response of that system. And Fourier transform of this system is h of omega. Fourier transform of this system is h of omega. Say yes or no. And this is obtained as minus j signum omega. Okay. So minus j signum omega. How it looks mathematically? See, signum omega is 1 and minus 1. So 1 multiplied by minus j will be minus j when omega is positive, and plus j when omega is negative. So this is h of omega. So if you are interested in its magnitude spectrum, then minus j's magnitude will be 1 and plus j's magnitude will be 1. So it will be 1 for all omega. Right? And if you are interested in phase angle, then minus j corresponds to minus pi by 2 and plus j corresponds to plus pi by 2. So we can say that h of omega magnitude is 1 for all the frequencies, so it is an all pass system. And for positive frequencies, phase angle is minus pi by 2. So we can say that this system is in minus pi by 2 phase shifter. So basically, a system whose impulse response is 1 by pi t, this is called as Hilbert transformer. For a Hilbert transformer, magnitude response is 1 and phase response is minus pi by 2. This means Hilbert transformer is an all pass system with a minus pi by 2 phase shift. Hilbert transformer is an all pass system with a minus pi by 2 phase shift. Is that very clear? Just go through this. These are the spectrum of Hilbert transformer. Impulse response of a Hilbert transformer is given by h of t equal to 1 by pi t. Spectrum of Hilbert transformer. Spectrum of Hilbert transformer means Fourier transform 1 by pi t. It is minus j signum omega. We derived this actually, and this can be written as this one mathematical. H of omega will be minus j for omega greater than 0, and h of omega will be plus j for omega less than 0. When you take magnitude response, this is the graph for h of omega. For magnitude response is 1 for all the frequencies. This is an all pass system. And phase response minus pi by 2 for positive frequencies and plus pi by 2 for negative frequency. Okay, yes sir, this is phase response. See, x of t sin omega t. So Hilbert transform of sin omega naught t, this will be sin omega naught t minus pi by 2. Okay sir, so it is minus cos omega naught t. Comfortable? So Hilbert transform of sin omega naught t is minus cos omega naught t. ऐसा आएगा. Next, Hilbert transform cos omega naught t. HT stands for Hilbert transform. So it is cos omega naught t minus pi by 2. So it is simply sin omega naught t. Is that very clear? Cos of minus theta is cos theta. So I have taken minus common here. This is not integrate property, beta. This is Hilbert transform. Hilbert transformer is utilized in FM in your communication systems, frequency modulation techniques. When Hilbert transformer is taken once, so sin omega naught t Hilbert transform. Sin, what should I write here at first place? Tell me. And what should I write here at the second place? Tell me. So number 1 and number 2. Everyone should respond in the comment box. Come on, fast. Hilbert transform of this function sin omega naught t. Shabash. So Hilbert transform of sin omega naught t is minus cos omega naught t, and minus sign as it is. Hilbert transform of cos is sin omega naught t. Okay. Now moving to the next question. Hilbert transform of cos omega naught t will be sin omega naught t, and Hilbert transform of sin omega naught t will be minus cos omega naught t. So one logic, one thumb rule can be created from here, that whatever is this x of t, if you are taking its Hilbert transform 2 times, that x of t will get multiplied by minus sign. So cos omega naught t 2 times Hilbert transform means answer is minus cos omega naught t. Sin omega naught t is the input, 2 times Hilbert transform means answer is minus x of t. Okay, yes sir. Hilbert transform of impulse function. Okay, so Hilbert transform of delta t. You know what is this Hilbert transform? Hilbert transform means that function convolution with h of t. What is h of t? H of t is 1 by pi t. So when a function is convolved with delta t, you would have seen in LTI system, the result is this adjacent function only. So Hilbert transform of delta t is nothing but 1 by pi t. Hilbert transform of delta t is 1 by pi t. When you take Hilbert transform 2 times, answer is minus x of t, and x of t is delta t. So answer is minus delta t. Now see here, Hilbert transform of delta t. If it is delta t here, Hilbert transform is 1 by pi t. So we can say that Hilbert transform of delta t is 1 by pi t, and Hilbert transform of 1 by pi t is minus delta t. Very good. Hilbert transform 1 by pi t is minus delta t. Comfortable with this? Yes, sir. Now see here. Find the energy in this signal. Please concentrate. So sin at upon pi t. I cannot find the energy in time domain for this signal. So what I am doing, I am just taking its Fourier transform. It is rect omega by twice a. Very good. So this will be looking like this. So energy 1 by 2 pi 1 by 2 pi minus a2 plus a x of omega magnitude square d omega. So x of omega magnitude square. So 1 square will be 1. So ultimately you need to calculate the you need to calculate the you need to calculate the area of this. So width into height. So a by pi should be the answer, Ashok. A by pi joules. A by pi joules should be the answer. Comfortable with this? For this question, x of omega spectrum is directly given, so energy will be concentrate, energy is 1 by 2 pi minus 1 to plus 1 x of omega magnitude square d omega. Okay, so students, when you square this, what you will get? See, minus 1, minus 0.5, 0, 0.5 and 1. Okay, so root pi by 2 square will be pi upon 4, and root pi square will be simply pi. This is square, x of omega magnitude square. This is an even function, na? Yes, sir, this is even function. So for even function, multiply by 2 and make the interval half. No need to integrate, because just you need to calculate the area of these rectangles, one rectangle and another rectangle. So this first rectangle, area of this first rectangle will be length into height, length into breadth, whatever. So 1 by 2 into pi by 4. And area of this bigger rectangle will be 1 by 2 into pi. So pi is taken common and cancelled. So 1 by 8 plus 1 by 2. We can say that 8 is the LCM. 1 plus 4. 5 by 8 आंसर आता है क्या? 5 by 8 joules. 5 by 8 joules. Comfortable with this? Can I have your response? So students, we'll stop here and we'll meet in the next class tomorrow. Okay. Next class is scheduled at 10 a.m. tomorrow morning. Are you aware of that? Since you are present in this class since almost morning 10 a.m. So we will be stopping it right now and we'll be connecting back tomorrow. So meanwhile, I can give you the idea about the test series. GATE and ESC test series link is given in the description box. These are the various features of the test series. Do subscribe this channel. Hit the like button if you have not done so. Tomorrow's topic, Fourier, we will be just continuing autocorrelation, cross correlation, then moving towards Z transform, DTFT and DFT. These are my topics. Students, just take the screenshot of this. Subscribe to BYJU'S exam prep, GATE and ESC. You can just subscribe, and this is the QR code given. Telegram channel link is also there. Thank you so much, Raghuram, Navneet, Chinmay, everyone. Thank you so much. Do subscribe our channel. Jai Hind, Jai Bharat.